Bismillahirrahmanirrahim. Good morning. Assalamu alaikum warahmatullah. So we have now presenter Professor Ali Hussain Mukabal. He will present about the research activities of the Research Center of Communication Systems and Sensing. Professor Ali received his PhD from Virginia Polytechnic Institute and State University, USA. He is currently a professor with the Electrical Engineering Department, KFUPM. He is also the director of Research Center for Communication Systems and Sensing. During his study at Virginia Tech, he was with the Time Domain and RF Measurements Laboratory and Mobile Portable Radio Research Group. He was a visiting associate professor with the Center of Advanced Communications, Villanova University, USA, a visiting professor with the Georgia Tech in 2015, a visiting scholar with KAUST in 2018 and 2019. His research interests include communication and sensing applications, include the direction of arrival estimation, through-wall imaging, localization, channel characterization, and ultra-wideband signal processing. He was a recipient of many awards in the excellence in teaching, advice, and instructional technology. He has authored 2 book chapters and over 150 articles. So without further delay, I will welcome Professor Ali Hussain Mukabal. Thank you.
Okay, assalamu alaikum wa rahmatullahi wa barakatuh, and happy good morning. The talk will be divided, so I will be myself, and then Professor Daniel, very well known, will take over at the end. Okay, so the objective of this quick presentation is to share with you how we contribute to the next G as the Center for Communication Systems and Sensing. We'd like to listen to you if you have inputs, and we'd like to showcase our work to our colleagues, our international speakers, international representatives of the industry joining us. So, okay. To turn things on. The laser pointer is working, but the clicker is not working. Can you put the presentation backwards? Okay, so the objective is to showcase part of the research going on in this university. And we are going through a transformation. So I quoted some of the statements by the president and the vice president to understand what is the meaning of transformation and where are we heading. I think in many universities, there is trends to go towards more challenging and critical work that yields tangible economical and societal impact, ultimately improving lives. So basically, the normal trend of publishing for getting papers is, in many cases, being phased out. At the kingdom level, there are priorities, and we have now the RDIA, the Research Development Innovation Association, and they came up with different priorities, including energy and industrial leadership, sustainable environmental and essential needs, economics of the future, health and wellness. And we mainly fit into the blue, number C, economies of the future. Under that, at the government level, at the kingdom level, also they came up with subsections, including C1, which is cognitive cities. So contributing to cognitive cities is where we fit as a center. Now, with the transformation we are going through, we have 4 different categories. The first category is interdisciplinary research centers. The second one is applied research center, joint research centers, and then we have research support. Now, the communication systems and sensing, we fit into IRCs. And the IRCs stand in the name to emphasize that we need to work together. So it's not just an objective, no, it's part of the title of the center, so we have to work together. And I colored 4 of them with yellow, so you know that we, communication system and sensing, are very closely working with intelligent secure systems. They have more of cybersecurity. We have intelligent manufacturing and robotics, and smart mobility and logistics. Applied centers usually do a service to the industry, and we have joint research centers established with other entities. So we could have Keysight, KFUPM, for example, lab in the future. Currently we have Sadaya, we have CAX Center, we have CACARE, and so on. We have also 4 supporting units. Now I'm looking from the top to show you where we belong. What we also did, when we have this center, communication systems and sensing, there was a valid question. What is it that we should do? So we visited the entire world, starting with Saudi Arabia, and then the Arabic region, Middle East, China, Europe, of course, United States, North America, South America, trying to understand, first, who really have a similar title, communication and sensing? Because communication systems and sensing, understanding the name of the center could imply what we should do. This is to our best. So basically, we searched for how many centers are there that really doing communication and sensing at the same time. And I think we mainly find in UK, Glasgow University and so on, they have this title, very similar title. And then also we look at sensors working communication only and working on sensing only. We're very lucky to have this name because I'm sure you know about the integrated communication, ISAC, integrated communication and sensing. It became natural to us. Being in Saudi Arabia, we understood who is in the region. We have also Professor Mohammed Salim Alawini from KAUS. We have Professor Khan from King Saud University. So we wanted to know what are their strengths, so we don't duplicate. We complement rather than, compete. And also we have understood what others are doing, what are the topics they are going through. And the distribution is not even at all. For example, in Algeria, for example, there are lots of centers in that field. So we learn from this. Now that we know where are we in the map, we want to grow. We want to see ourselves part of the important centers. It might take time, but at least we have a vision of what's going on around. So I'll just move through this map. Now, understanding what are the topics of importance to other centers, visiting their website, identifying their department or center managers or directors, we notice we have 4 different elements. We have communication at the top, we have sensing, and then we have supporting fields, including signal processing and radar and localization. Why these specific fields? Because we are establishing a center in a coexisting university, so we want to make sure that we co-align. We just don't put objectives and then the faculty we have, they don't match with. So this is why we identify these regions or fields of interest. Then we identify the grand challenges for the center, and I'm focusing on only the parts that relate to the next G. So we have 2 main things. One is related to the national security needs. So develop holistic designs that span multiple disciplines of signal processing, communication, sensing, machine learning, and big data addressing public safety and national needs. The second grand challenge, and this is part of the Kingdom Vision 2030, is to reduce the consumption of resources and reduce the emission of CO2. So there is more emphasis on green communication and green sensing. The term green communication might be very well coined, but we are extending this to also green sensing. This is just a side note. Yesterday, he gave me, I tried to give him my card. So he said, I want to save a tree. I will just take a picture. So I told him, I'm not sure if taking a picture will save a tree. You know that 1/3 of the power consumption in the world is in IT. So we also have to watch for the power consumption for communicating text or messages. All right, so this is the main challenges for the center. Then we have, this is just to show you the structure, maybe it's not very important now, but we have advisory committee, of course, including Professor Daniel, our distinguished professor. We have Professor Salam Zammu, Professor Munir Al-Absi coming from electronic background, Dr. Ibrahim Naib from sensing and electromagnetics. We have Dr. Suhail Al-Dharrab, who is also assistant dean for research, and myself. And then we structured the center to serve the objective. Now, we have to have capabilities, right? So we are capitalizing on what exists and building on that. So, okay, I'm sure you cannot read this, but just to show you that in our website, we have a website, and the website is populated with all the resources that we have, so you know what we have. Just to give an example, we have the Keysight Agilent or Keysight Field Focus handheld analyzer. We have multiple of that. We have 25 gigahertz, 26 gigahertz, 50 gigahertz. And we have, of course, multiple directional analyzers. We have, we are very good, I think, relatively good or excellent in terms of software-defined radio. So we have lots of types of national instrument software-defined radio. We have, of course, the NARDA system. They are in the exhibition outside. We have also, the fundamental equipment, scopes and what have you. We have some of this equipment existing, and we are getting a lot of support from the university to upgrade. We're hoping with our industrial partnership here that we can go into the right direction instead of, doing inefficient acquisition of equipment. We recently acquired antenna chamber, thanks to the university support. We have 5 million, approximately 5 million riyals for the chamber. It will be ready by May 2025, so about 4 months from now. We are also building our capability when it comes to software. So we have HTZ software, Opti systems, and so just to give you an example, we have others. So for more, you can visit our website. So the idea is to show you where we belong. Part of the things we do also is to invite international speakers. We have inbound program where we have scholars coming, visiting Saudi Arabia, visiting the university, and it's well supported. And we are, if you see the timeline downstairs, we have visitors from all over the world, from Canada, Australia, China, wherever. So we're trying to bring expertise in and improve our visibility and connection. And this event, of course, is one of what we are trying to do. Now, expanding more with the industry, we just have seen yesterday that we have the Keysight agreement with we also are working with another agreement related to radar. So there will be another memorandum of understanding under process. It's the objective of that is to build our capability in radar. Okay, now that we have the umbrella, what is really inside? We're working together in close agreement with the electrical engineering department. So there are some things managed by us or not. What you see on the side is just a rack of software-defined radio where we do MIMO system applications, including angle of arrival estimation. Okay, so we have in the center 5 main labs. The first one is the Telecommunication Research Lab. The second one is Advanced Applied Electromagnetics, Optical Communications and Sensing, Advanced Electronics. So we have communication, if I may divide, we have electronics, and then we have also the DSP, the digital signal processing capabilities. I'm putting asterisks on some of them because, as I said, it's joint managed with the electrical engineering department. Okay, now I will share with you the subgroups, and I'm showing the pictures of my colleagues. I might invite some of them to the stage later on to just introduce themselves and to make the session more lively. When it comes to communication, that's pure communication or directly into communication, we have Professor Salam Zamu. He's here, right? Okay. Dr. Salam has been with us for some time. He has graduated many PhD and MS students with excellent capabilities. I think they're worldwide now. Luckily, you travel somewhere and you find some of your students in different countries and contributing to have like grandsons, okay, in academia. We have Professor Daniel, and he will be on the stage. We have Dr. Khalid Rabia, I think is here or not. Dr. Khalid Rabia is a distinguished associate professor with the COE department, with the computer engineering department. So hopefully he will be in the panel discussion. We have Dr. Sahel Darab, who was also in our advisory board. Dr. Ali Nasser, I will invite him later on to the stage to give a quick follow-up. Dr. Samir Al-Ghadban, Dr. Saad Al-Ahmadi, Dr. Wissam, Dr. Anis Al-Jabli also, I'd like to invite him later on. Dr. Akram and Dr. Suhaib, Dr. Farouk, and Dr. Mahmoud. On the right-hand side, we have 2 postdocs. So the university is very active in hiring postdocs. And we are growing in the number of postdocs in an exponential way. So this is something that is improving the research capabilities. Because we know that usually faculty are overwhelmed with teaching and others. So we are very active in that. I'm sharing some of the keywords that are currently, we got these keywords from our professors, our affiliates. So we have people working on RIS, Reflected Intelligent Services, ORAN, optimization techniques, cognitive cities, communication systems, signal processing, and AI. Now, if you want to say that we have a subgroup of this, they are still in communication, but there is more focus on integrated communication and sensing, including myself, Dr. Mohammed Hassoun, Professor Amr Bahati, he's a radar, Dr. Saleh Al-Aoush, Dr. Ali Nasser also, and Dr. Farhan. We are trying to focus more on localization aspects and radar. So the keywords are very much the same. Now moving forwards, we have a group in advanced electromagnetics. We have professors visiting from Jeddah University. Dr. Abdullah Mansouri is the chair of the electrical engineering department there. And these are some of our colleagues working on EM, Professor Khurram, Dr. Hussein Atiyah, Dr. Abdullah Garni, Dr. Ahmed Umar, and I will explain more about Dr. Ahmed Umar because I'm sure he had some samples here. I will share it with you. Dr. Ali Rashid, Dr. Yazan Al-Alam, and we have also Dr. Kumran and Dr. Muhammad Halimi. Okay, so this is mainly on electromagnetics. We are good, I think, very good in antenna design and what have you. We have also the microwave biosensing, includes Dr. Ibrahim Naib, Dr. Yaqub Mahnashi, Dr. Sharif Sheikh in microwave, Dr. Abdurrahman, Dr. Abdullah, and Dr. Abdurrahman. The keywords here, we have antenna, sensor design, medical application, carbon, dielectric material, and fiber optics. Then we have the integrated signal processing or intelligent signal processing. We have our VP, Dr. Al-Sheikhi, Dr. Mudassir Masoud, Professor Azzeddin, and Dr. Naveed, and Dr. Abdul Majid. They're doing signal processing, deep learning, machine learning, protocol design, and wireless networks. And we are very happy to have a very good bunch of servers and workstations with high processing capabilities, including advanced GPUs. And they are, I think, we are lucky to have them. They are really costly, but the university is giving us a lot of support. I think we have maybe 8 of them with very high GPUs. And of course, memory size. If I tell you what the memory is, you would think it is a hard drive, and I think we are lucky to have them. So then we have the electronic and large-scale integration. Okay, we have 2 parts here. There's a very strong push from the administration to have prototypes. So, and, you know, whenever it comes to real world, you need electronics guys, so just to implement things. So we have group in electronics, and we have groups in electronic design. At the kingdom level, there is now ALAT, and there is direction towards fabless or design ICs here locally. So we have very fresh graduates from very high qualified universities, and we are making a subgroup to work on that. So we have electronics, sensor design, medical application, carbon, terahertz, and electronics or green electronics. That's a quick idea about who we have, and then I will invite some of my colleagues to come to the stage. Okay, now I will share with you some of the projects we are doing. I will start with the external projects, some samples, so you have an idea, and then I'll go into internal projects. So we are, as I mentioned yesterday, we have good relation with CST. The first project we had was analyzing the impact of wave ducting on international mobile telecommunication frequencies and investigation of anomalous propagation. I'll talk about that more. We also have another project related more to signal processing, and that's flow production monitoring. It's not directly into NextG, but just to show you that we are having some projects there. This is one of the projects we have finished with CST. It was, I think, one of the things we are proud of. It was in a consortium work with King Saud University, Dr. Khan, and also we have Dr. Mohammed Salim from CAST. So we worked together. The title was Sharing and Capability and Compatibility Study of Sub-700 Megahertz. So the idea was to connect the unconnected. Dr. Salim Alawini, if you remember his talk. If you keep using higher frequencies, then the coverage will be small, and then you need more cells. Sometimes the population does not justify this. You have to have a lower frequency and extend the band. In Saudi Arabia, the sub-700 megahertz is not used for digital TV. It's usually dedicated for terrestrial digital TV. But Saudi Arabia can stop this because it's not being used efficiently here. But you need to convince all other countries around you and the world. So there are some countries from Europe who are supporting the movement. We have engineer Al-Maghrabi here, and of course he knows more detail. So the idea was to convince the community, the international community, that we can still convert our TV towers into mobile towers and extend the coverage. So we did interference analysis across the entire kingdom. That's a huge amount of work to find what is the coordinated distance and what have you. So this is one example we think we're proud to work with CST on. our next project, if I don't know if you know or not, but Saudi Arabia is, or the Eastern Province, is the best worst, I don't want to say worst, the best worst ducting effect in the world. So during the Gulf War and so on, people are putting radars in their airplanes, and then they expect the coverage to be, let's say, 100 kilometers, for example. But then they receive targets from 300 kilometers. A huge amount of difference on the expectation. So it turns out that we have a huge ducting effect, which means the wireless signals get trapped. Okay, so what we are doing, I'm not trying to explain the entire project, just to give you an idea. So forgive me for going a bit quick. So in order to understand what's happening on the air, this happens if the temperature goes, usually if you go up, the temperature goes down, right? But here in this province, especially in May, June, July, if you go up, the temperature gets warmer, gets hotter. And this creates the ducting more than other locations. So a base station, for example, in Iran could connect your mobile phone here, which is far distance. So you need to understand what's going on. So to do that, you need to have measurement of temperature, pressure, and so on the air. So we designed, this is just, let's say, a proof of concept. We designed a small circuit with controller to get all the required parameters, sensors, temperature, pressure, and what have you. Okay, we cooperate with the aviation department, aviation center, and we connect the tools, and we did an experiment. I don't know if the video would work or not. Okay, so basically, I don't know if the controller can press on the video, but basically this shows you an example where we fly the drone, and it has to go up on the air. There are some drones that can go 12 kilometers, 5 kilometers, so if you want to understand. But for 6G and future applications, at least you need a few hundreds of meters to understand what happens there. Okay, so this is just one of the experiments this is in the university stadium, and they're just showing an example where we did take real measurements. Of course, we also rely on other measurements coming from international websites and so on, but we have problem with them because here we really need larger resolution, like every 1 meter or so, you get more data. You will not see the drone, and it is, of course, a very challenging task because you need permission to fly and you need all specialized people because we need to go high. Okay, so another example which we also did in terms of, as I mentioned that I think in all universities, as I heard from my colleagues, that there is a pressure towards products. We don't want just papers. So we also have drone detection, proof of concept, where we have fish cameras and eye cameras, and then we use acoustic with combine things together. Of course, many people are working on this problem, but we noticed that the sky in Saudi Arabia is different than other skies, okay? Because of the dust, the environment, and so on. So there is no vegetation as much as you have in Europe or so. So we have to have our own database. If you use the databases that are on the internet, the probability of success will be different than otherwise. We also have, of course, in the sensing part, we have some work done. I'm just going to skip this quickly. Those are some examples where we show the external projects and the prototyping trends that we have here. So now I'm moving to the projects that we have done. The university gave us internal funding, and we have a project committee inside where we try to align and review them internally and give chance for our affiliates to work on their research problems. So we have about 1 million riyal every year where we try to distribute that in a fair way. I picked these are the titles of 2001, 2000, where the center started. You don't have to read all of this, but I picked the green words, so if allow me just to read the green words, which highlights what are the topics we're working on. Sensor-based adaptive algorithms for application to big data in IoT wireless sensor networks. We have millimeter wave, next generation flexible access networks, artificial intelligence and deep learning applications, terahertz communication, beamforming, optical beamforming, resource allocation optimization, massive MIMO, direction of arrival estimation, underwater communication, age of information, this is the second year, integrated communication localization and sensing, beamforming, 5G, 6G, free space optics, wireless, 6G inspired satellite aerial terrestrial networks, hybrid RF FSO multi-UAV communication, active risk empowered multi-user terahertz communication, reconfigurable antennas, HMIMO, secure vehicle communication, NOMA, ad hoc underwater communication, reconfigurable on-chip shared antenna. We have some integration now between antennas and electronics. We have transmittive polarization and rotator surface for smart communication. We have RFDC converters, electronics. We're pushing the electronics guys towards communication. And we have RIS-aided federated learning, as we were going to see. Okay, so now I showed you an idea about some of the external projects, some of the current projects. As I said, the objective of this is to show how we can collaborate. Now I will share with you some of the slides I asked some of our respected affiliates and postdocs to share their background and what you have in a minute or so. Dr. Ahmed is supposed to be here, but he is teaching a class. And I thought to share with you that he's working on the area of applied electromagnetics, next-G antennas design, and reconfigurable intelligent service design. And one of the things he is doing, he started working in these reflected surfaces, just to show off that we have some real work going on. This is the first level where we have 15 by 15 elements. And then, of course, the next stage is to make them active and get control and so on. But this might take some time. We try to acquire this from many different locations. But unfortunately, I think none of them is at the ready level. So they give you one single frequency that you can operate on, and your job will be just to switch on and off. This is not a research work. So we will have to do things here. Next, I'm inviting Dr. Ali Nasser. Sorry, can you, Dr. Ali Nasser, just for a minute or so to...
So in this project, basically, we are trying to study the challenges of high-frequency communication, and we're trying to address those challenges. So to name a few of those challenges, we know that high-frequency communication is very susceptible to obstruction, and so here we can use basically reconfigurable intelligent surfaces which can assist communication between the base station and the users if the direct path is blocked due to obstacles. And the second challenge is beam splitting effect. So we know that if you're using high-frequency communication over wider bandwidths, then the beam splits, and if you're trying to focus the beam towards the target location, its energy is split into sidewise directions, which basically results in SNR loss in the specific target direction. So in order to address beam splitting effect, we can use time delay units. We can deploy them between digital beamforming and analog beamforming stage, and there are other solutions. We are trying to basically look towards those solutions. And the third challenge is near field communication. We know that when we go to higher frequencies, then the Rayleigh distance, which basically defines the boundary between near field and far field propagation, that expands significantly, and it's more likely that the communication that we basically conduct is happening in the near field of the transmitter. And then we have to consider basically near field channel modeling, beamforming changes into beam focusing. So we have to basically address those challenges. So in this project, we are trying to basically address those challenges, and there are few of our recent research works. Thank you.
Okay, so Dr. Ali took more time because he is the session chair. Dr. Ali, mashallah, has a lot of publications, and I hope that you have a chance to collaborate with. Our next speaker is Dr. Khalid here. I think he will be the panel. He will have a chance to present his work. But Dr. Khalid is also joining from UK. He is working on security of 6G technologies, cross-layer optimization, and UAV-aided communication systems. This is some of his recent publication, and he won some of the awards received. Our next, we have Dr. Sahel Al-Dharrab. Please, Dr. Sahel.
Good morning, everyone. My name is Sahel Al-Dharrab. I'm working basically on physical layer aspects of wireless communication systems. So I basically study the outage performance, outage analysis, and all of this for the communication systems. I will try to tell you something behind the slides. So the first thing is that I owe the credit for the graduate students. So I have worked on the detection of malicious UAV. which is a challenging problem where the UAV is basically having a small radar cross-section, and at the same time it's at a low altitude, so we have a lot of clutter, and at the same time also they have a low speed. So that's one of the challenging problems of the detection of the UAVs. I have Yusuf Awad, who joined KAUST for his PhD, who worked on this. Abdullah Al-Shammari, who is working on SABIC, also worked on this problem. So that's one of the problems I worked on. The other thing I'm interested also in the non-terrestrial networks. I'm happy I had interesting talks yesterday. It was very enlightening, and I enjoyed it. Also working on the mixture of RF and FSO. I have also one student, Abdullah Saleh, worked on the use of the UAV in the integrated sensing and communication system, where he's using deep reinforcement learning. So this is just a brief idea about what is my area. Thank you.
Thank you. So, okay, so next we have Dr. Yasser Jabli. I'll try to be faster, sorry. For some of my colleagues that did not have a chance to present, we will be sharing the slides with our respected guests and attendees to know more. So,
Assalamu alaikum. Hello, everyone. My name is Anisi Gibli. Actually, my research focus is in the intersection of wireless communications and machine learning. In one hand, how to design the communication systems and manage the communication resources in order to enable communication efficient and privacy-preserving machine learning. On the other hand, is how to use machine learning techniques and tools in order to solve complex problems in wireless networks. The project that is shown here is actually under the first category, where we design and manage the communication resources in order to enable communication efficient federated learning. So just to make it short.
thank you. So please feel free to chat with our affiliates after during the coffee break or so. I will. Dr. Hussein, I think, is not here, so I will just go over the slides and I will give my short. Dr. Hussein is working in applied electromagnetics for biomedical and wireless applications. We have Dr. Abdullah is working on antenna and microwave applications. We have Dr. Wissam, is not here, working on areas of specialization, wireless communication, next-G federated learning, security, privacy, and resource optimization. We have, this is now a list of some of our postdocs we are proud of. Dr. Mahmoud is working with me, and we have Dr. Abdullah is working in signal processing related application, atmospheric channel modeling, EM beam propagation. And this is just a picture to show the direction of work. We have Dr. Farouk. He is orchestrating the event, and he's working on high mobility networks and grant-free non-orthogonal multiple access. We have Dr. Abdullah. Abdullah is working very hard, but he's more on the sensing side, and he's working on dust sensing, a difficult topic. We have also our Dr. Ahmed Rida. He's more in the RF design. He has excellent experience. He worked in China, and he's now joining us also. And he is also working on design for communication applications. We have Dr. Kamran Ali. He's also working on the area of more of optics. So we have different combinations. Okay, so I'm trying to conclude now. So basically, here is our dream mission is to have relation with the government, industry, defense departments, local operators, and of course, academia. We have Keysight in the picture. Now we have also important companies around us where we're trying to build up our capabilities. We have good relation with CST. We have Dr. Engineer Ayman with us here, and we are targeting this. And we hope to add your logo if it's not here, IRS Wireless and others, to our list, and we have excellent collaboration. Okay, so if you want to know more about what the center is doing, then we have our LinkedIn account. We have a website populated with lots of resources. Now, I would leave the chance for my colleague, Dr. Professor Daniel, our distinguished professor, to give some highlight about his research. Thank you.
Thank you very much, Professor Ali Mukebo, for introducing the center, what you are doing in terms of research. Actually, we have an amazing team in our center doing a great job. So I'm going to present some slides more about this roadmap towards next G and provide some insights and what I think is the best way we should proceed in terms of research and how we're moving forward. I think is really important. And actually, we are guiding our discussions based on what we have and what has been formalized, announced by ITU in 2023. So we have this figure is very well known. It focuses on the new usage scenarios for 6G. So we are expanding the triangle in hexagon with some new capabilities and extending the existing capabilities for 5G to make it more, I would say, impressive. And, but the main idea, actually, we should focus on the 6G technology development and make sure that they will provide greater communication, sensing, and localization capabilities. Focus on the innovative services is not the moment. I think the future will tell us which innovative service can be built on the 6G network, when they will be delivered, and how to monetize. Right? We remember that you are still at stage number 2. So it's only when 6G reach its trial phase, validation, is that the innovative services can start. We can start working on that. And proceeding this way, focus on the 6G technology and letting the services to the next stage would avoid a kind of dissemination. We are not sure it will be delivered, as happened with 5G. The 5G, it announced the new services before the network has been launched. And this was one of the points which caused to the public a kind of dissatisfaction. Okay? So we are guiding the discussions on such kind of framework. I talk about the next G trends. It's aligned with the summit team and what we are expecting. And some of this research we are doing in the center, and I'm confident it's worldwide. We are focused on this specific direction. The first point is, in order to satisfy all those new requirements and capabilities, we needed to evolve in some specific technologies. For 5G, we have massive MIMO, which is one of the pillars for 5G. For the next G, we should evolve, towards an extremely large-scale multi-antenna. So when you go for an extremely large-scale multi-antenna, you can have either a discrete and a continuous aperture. And this will change completely the way you are going to model, you are going to evaluate the system. It's not only an increase in the number of antennas, but it will change the electromagnetic properties of the environment, which means that we are working now with spherical waves instead of planar waves. We'll be working the near field instead of the far field. We have now spatial non-stationary, which means that we have different visibility regions, as you can see here. Conventional MIMO, usually the array it covers all the users. But when you have an extremely large array, you have different parts of the array covering a specific number of users. We have a super resolution because now we are focused not only on the angle, but on the distance. And you have also a beam focus design. Instead of a beam form, you have a beam focus. So this is one of the trends that will be part of the future and will enable us to implement these innovative services. Another technology which is a long time under discussion is reconfigurable intelligent surface. It is well known. I think it has a key role in guaranteeing a sustainable capacity growth. This is really important because we can see in this figure number 1, you have the mobile traffic, data traffic increases exponentially. So how to keep, based on this exponential growth, how to keep the energy consumption, the cost, the complexity in a certain level. So in reconfigurable intelligent surface has a huge potential. So it can be used to emulate a massive MIMO array. And in addition to that, based on its properties, we can manipulate the electromagnetic signals which exist in the environment. You are not generating new waves. You are recycling the waves which exist in the environment. And also, we can use the channel as an additional, parameter in the optimization process. So usually when you optimize the system, you consider the transmitter and receiver. And the channel is not part of this optimization. But if we are able to manipulate these electromagnetic signals, we can use the channel as part of the optimization. But of course, there are some challenges that we are working on that. The community, the channel estimation, we have a beamform design at the base station, at RIS, we have a RIS deployment, among others. Another trend, which is extremely important, you part of, you contribute for the innovative services you expected when the 6G network infrastructure is launched, is holographic MIMO. Different from RIS, you are focused on active transceivers. So basically, you have two procedures as part of the construction of this holography. Is the recording and the reconstruction. You have reconstruct the amplitude and phase of the wavefronts. And this is also in a kind of array with extremely large, but instead of working with these discrete elements, you have a kind of continuous aperture. Okay? And this is the working principle. I will not go in the detail because of the time. Okay? But basically, you have the waves, two waves, object wave, reference wave, and the difference between these two waves will able us to reconstruct the amplitude and phase of the wavefronts. Another concept which now is under discussion is fluid antenna system. Is really interesting, and it's based on the Bruce Lee philosophy, be water, my friend. So if you put water in a cup, it becomes the cup. If you put a water in a bottle, it becomes a bottle. So now, if you put water in a teapot, it becomes a teapot. So the water can flow and it can crash. So be water, my friend. So this is the philosophy, and how we can associate that philosophy with our technology scenario. So basically, since we have the water it's formless, it can move to any position. So basically, you can have antennas with formless, shapeless, like fluid, and you can adjust. And at the end of the day, what we want to create is a truly massive MIMO. Because when you talk about massive MIMO, usually massive number of antennas just at the base station. How many antennas we can implement in our cell phone? We have limited space, right? And here is a concept in which we can implement a massive MIMO in the cell phone. We have this fluid, the liquid, in which the position of your liquid will define the position of your antenna. So we have a great flexibility. Okay, there are some explanations, but you can explore the spatial diversity, and again, based on the position, you can find the position which will provide you the better gain. So fluid antenna system, or movable antenna arrays, it's another terminology, has been considered as another trend in next. Cell-free massive MIMO, it goes beyond the paradigm of cellular networks. So cellular networks are very traditional concept, but there are some limitations, and basically is a network-centric approach, and we have some drawbacks. And 4G try to overcome these drawbacks. Okay? We have a distributed MIMO in 4G, but still, we cannot guarantee a uniform coverage. We still have, users are still facing some interference from adjacent clusters. So we are not able to fix all the problems regarding such, interference, coverage, etc. So the cell-free massive MIMO is a new concept. And it aims to aggregate in the same concept, user-centric approach, distributed MIMO, and ultra-dense network. And basically, you have a large number of distributed access points connected to some central processing units, and you work in a network MIMO fashion, with now you have users surrounded by access points. Okay? So under this paradigm, you can make the interference more manageable, and the channel estimation signal process can be performed locally. Of course, and again, guarantee microdiversity, again, uniform coverage, but there are some challenges. Integrated sensing and communication, which is working, the center is working very hard. I will not take much time, but I think the trend is to consider ISEC in the near field domain, because it's where we are being, the users will be placed. So for the near field, you have some new properties that should be accounted for and should be explored. Non-terrestrial networks is another technology which is really important. Professor Luini gave a talk yesterday about that. So the basic idea is to connect the unconnected, or we can also integrate all the layers, ground, terrestrial, air, space, and see how you can guarantee harmonious integration. I think this is the most challenging part. You have different layers, how you guarantee an harmonious integration in all the layers. Wireless energy transfer, harvesting, backscattering is really important for the energy efficient perspective. High frequency communication, this is the way you are moving to get more data rate, but there are the pros and cons, and this must be considered in any communication design. Here, I show the pros and cons of each frequency range. The standardization is still ongoing. You have, for terahertz, it's still at the early stage, but there are some, in ITU, there are some study groups working on that. The same for millimeter wave, VRC, FSO. We have multiple organizations working on that standardization process. So next generation multiple access is another direction we must work on. Why? Because we are dealing with a multi-user setup. So if you are dealing with a multi-user setup, it's natural. We have interference, multi-user interference, and how to deal with multi-user interference. The strategies we have now, they are not too flexible. They are efficient under certain conditions. For example, you use SDMA, space division multiple access, in 5G. 5G is SDMA and OFDMA. It's a combination. But SDMA is work well first when you are dealing with low interference regime, which means that the interference must be within the noise level. When the interference is very high, you are not able to mitigate interference. And it's suited to semi-orthogonal users, which means the channel must be similar. And more importantly, it's optimal only when you have perfect channel state information. And in practice, there is no perfect estimation. So this is what we have in 5G. And during the 5G roadmap, many people study NOMA. NOMA is another multiple access strategy, which is non-orthogonal. It's basically, instead of treating interference as noise, as SDMA, NOMA, you decode interference. But having such a kind of strategy, this makes NOMA suitable when you have high interference. It means that for low interference, NOMA will not perform well. And also, it's good when you have a disparity in the channel strength. So comparing these two scenarios, we see that they have a fixed working principle. Which means if you are in a network with different conditions, we cannot use one or the other to mitigate interference. And for the next G, it requires a more general and flexible framework. And one solution that it's now in the discussions is to use a strategy called rate splitting multiplexes. Instead of fully decode interference, or instead of fully treat interference as noise, we can partially decode interference, and then the remaining interference will be treated as noise. It means that to have a high interference, you reduce interference to a certain noise level, and then use SDMA. So you are exploring, the capability of SDMA, but guarantee SDMA will work efficiently. Another direction is the semantic goal-oriented communication. This is extremely important. So the idea is to go beyond the Shannon theory. So not the case how to transmit, but what to transmit, and the information is the meaning. So, and basically, we needed to transmit what is extremely necessary. Okay. So we are working now not only in the level A. So these are the levels that defined by channel. So we work on the semantic problem and the effectiveness problem. And this will change completely the theory behind communication, and it requires a new theory, semantic theory, to build the principles, the foundation of such kind of approach. And finally, digital twin, which it has been in discussion. Dr. Michael from KeySight gave a talk yesterday. I'm not sure if the next G killer service, and people don't like this kind of terminology, but the point is, for the next G, we needed to see what will indeed change our lives, what will be a revolutionary change. And it takes time. And sometimes when you predict something, it will completely be different at the end. The initial vision will change over the years. But for digital twin, it has a huge potential to be one of these players in changing the lifestyle, guaranteed performance improvement. And just to highlight, we started working with KeySight, and hopefully over the next years we will be building a digital twin framework to KFUPM. Okay, here is a picture. So we are working on that, integrating ray tracing, creating some high fidelity models, providing the data validation. And for the measurement scenarios, we are still under discussion to see which area we are going to cover. So this is a brief summary about the next G trend. Okay, unfortunately the time doesn't allow me to go more in detail, but I'll be open, more than happy for questions. Thank you very much.
Thank you, Professor Liusan McCabe and Professor Daniel. So if you have any questions, so we do not have much time, so we can just take one question for now.
Good morning, doctor. Good morning, everyone. I have a question. I am master student in electrical department. My concentration is control, and you can help me maybe with some guidance to the underwater communication, doctor. What is the state of the art in this topic of research? Thank you so much.
Thank you for the question. I'm not an expert in underwater. I know there are some research in that layer. And in terms of the state of the art, to tell you now, it's not straightforward. We needed to go in the literature, IEEE Explore, but basically we should consider integrating underwater with the other layers to keep the connectivity. and finding what is the best communication setup using, for example, can use acoustics for the communication or even free space, some lasers that it can guarantee a more, I would say, directive link. But the state of the art, this is it's in a constant update. So you should, I mean, check the latest advances. But there is a strong research and worldwide work in that field. But to tell you now the state of the art, I'm not an expert, to be honest. I'm not working with underwater. So maybe some of my colleagues could. Okay?
Okay, thank you so much, Doctor.
Okay, thanks, Professor Daniel. So, if you have any other questions, please feel free to interact during the coffee break session. So now I will introduce our next keynote speaker, Professor Muhammad Khurram Khan. He is a professor of cybersecurity at King Saud University, Saudi Arabia. He is also the founder and CEO of Global Foundation of Cyber Studies and Research, USA. He conducts world-class research, consults cybersecurity organizations, and helps startups and early-stage companies in their strategic missions of R&D and market growth. He is the editor-in-chief of Telecommunication Systems, published by Springer Nature. He is the area editor of cybersecurity in IEEE Communication Surveys and Tutorials. He is also an associate editor of several IEEE transactions and journals, including IEEE TIFFs, IEEE TIV, IEEE Communication Letters, and IEEE IoT Journal, among others. He is an author of more than 500 research papers and an inventor of 15 patents in cybersecurity. He is the chair of the task group on child online protection in the metaverse for the ITU, which is a specialized agency of the United Nations for ICT. He is a fellow of the Institution of Engineering and Technology, UK, and a fellow of British Company Society, UK. Thank you. So without further delay, I will welcome Professor Muhammad Khurram Khan.
Good morning and assalamu alaikum. Thank you, Dr. Ali, for the introduction. First of all, I would like to express my profound gratitude to KFUPM for hosting this wonderful event and inviting me to deliver this keynote speech. I'm very much grateful to Professor Daniel, and some other colleagues here who are, organizing this event, which is very impressive, to exchange the knowledge, to learn from each other, and to see that what kind of researches are being done at KFUPM, especially if I'm coming from KSU. So we are, local universities, so we need to establish our collaboration, we need to exchange knowledge, and we need to, also make impact on the society. So it's very imperative, in the current times. Yeah. So today I'm going to talk about a little dark side of the things which have been discussed earlier, because we have been discussing about the connectivity. And of course, connectivity and communication is very important for the modern hyper-connected world. But on the other hand, we have some pitfalls and downfalls of this technology, which can be harnessed by the hackers and nefarious, actors, bad actors, who can compromise the security of our systems and networks, especially when we talk about the mission-critical systems, critical infrastructure. So I'm just going to deep dive into some of the challenges we have, especially for the connected and autonomous vehicles, as well as I'm going to show you some of the research frontiers in this area and what kind of work we have been doing at King Saud University. So before I start the presentation, I would like to just market our center, which is Center of Excellence in Information Assurance, that was established in 2009 at KSU by the generous funding of Ministry of Education at that time in Saudi Arabia. And this center was basically under a program of Ministry of Education in which they established almost 10 research centers of excellence in the whole kingdom. I think there are 2 or 3 centers at KFUPM. We have 4 or 5 centers at KSU and a couple of centers at King Abdulaziz University. We got 6 million real funding from the Ministry of Education in 2009, and I am fortunately one of the founding members of this center. And this center was inaugurated by the former Crown Prince. He inaugurated in 2009 when he was the chief of Saudi intelligence, Prince Mukhrin bin Abdulaziz. And we have more than 40 staff members working in the center doing research from different perspectives of cybersecurity. For example, from network security, digital authentication, connected system security, especially when we talk about the cyber physical systems, IoTs, and so on and so forth. And we also do some research from the perspective of GRC, that is Information Assurance, Governance, Risk, and Compliance. And because the mandate of the center is not only pure academic research, we have 3 different dimensions of work. One is the research, which I mentioned, and second is the consultation, working with the industry, with the public and private sector organizations to solve their problems, And the third is like training to build the capacity in the kingdom and the capability of the human resources in different organizations. So there is one more aspect of cybersecurity which we do is about the public policy research, and we work with public sector organizations, for example, SADAYA or Hayat al-Amn al-Sabrani, National Cybersecurity Authority, or ministries, Ministry of Defense, Ministry of Interior, or Diwar al-Malaki, Royal Court, also to give them insights about the current and the future cybersecurity challenges which our nation will be facing, and what kind of challenges are there which we need to critically solve, and address them. Otherwise, it's going to become a very big national security threat for the country. So these are some of the, aspects of the research which we are conducting. And if you have any kind of interest in research in cybersecurity, please feel free to contact us and visit our center at KSU in College of Computer and Information Sciences, and I would be happy to host you. Okay. So, as we have discussed over the last 2 days, that we are living in a modern technological era in which everything is becoming a computer. So, because of hyper connectivity, the computational power we have, and the intelligence of the devices is ushering into a new arena. Where like you can do whatever you want with the small, tiny devices in your pockets. For example, smartphone or smart IoT sensors, which can be equipped anywhere in your home, in your industry, and you can do, and you can watch, you can monitor what's going on around. So perhaps 30, 40 years back, if somebody talks about drones delivering the food and autonomous vehicles driving you to your destinations and having some kind of robots working in the organizations, so it could have sounded something like coming out of sci-fi movies. But as the technology evolved, over the years, over the decades, so we have seen that this is becoming the reality. And I'm going to give more of the glimpses into the technology which actually we used to see in the movies 30, 40 years back, but because of the connectivity, because of the computational power and intelligence of the devices and systems, so this is all becoming the reality in the modern arena. So, because the topic of discussion is about the mobility and smart vehicles, so I actually took this definition of smart mobility from a book, The Mobility Revolution, written by Lucas Zimmerman a decade ago. So if you have interest in smart cities, cognitive cities, for example, we have been discussing, KFUPM has interest in that area. So this is a must-read book to know that how the future of the mobility would look like. So what exactly is the mobility, so smart mobility? So basically a new and revolutionary way of thinking about how we can get around, one that is more safer, cleaner, and more efficient. So that is the very important concept for the mobility, that we have zero emissions, like we have electric vehicles or hybrid kind of vehicles or whatever, new energy vehicles. We have zero accidents because the systems are driven by artificial intelligence, so they are more efficient than the human in the decision making in the real time. And then we have the zero ownership, so because of the traffic jams everywhere and cost of owning a car and taxes, So that is very important, that we do not own the cars, but it is shared mobility, like you have Uber or Careem or whatever, this kind of companies, or whatever, like you have the metro or modern mobility systems. So the society has a lot of benefits, and there are a lot of benefits for the smart mobility at the individual level. When we talk about it's going to save us billions of dollars, and going to protect the lives and save the lives of the people, and going to have a lot of impact on our society in terms of when we talk about the sustainability and sustainable environment. And then we have new business models to be created because of the smart mobility. It's going to create new business horizons, startups, and new avenues, especially when we talk about the data monetization, because data is becoming the new oil, and there is a lot of productivity for startups. And I have witnessed myself over the few years, there have been a lot of unicorns just established in this domain. So we were, just one of my friends, from China, actually, I want to quote him because we would do the research together. So he was just graduated in 2016 as an undergrad, and just last month I was talking to him, and he has a unicorn now, and he's doing the cybersecurity for the automotives, and it's a very big company because electric vehicles is booming these days, and there is a lot of challenges people are having, and people don't know about the risk and security and privacy risks they have. So there is a lot of demand, not only from the people, not only from the companies, but it's a regulatory requirement, in every country, and compliance requirement. So a lot of startups are mushrooming in this area, and they are just making a lot of and tons of money. And some of the glimpses which are just becoming the reality. For example, we have in China, we have 5G-enabled self-driven public transport buses which are running in the streets. You can sit in there, and they are completely autonomous. And we know that Tesla has built a logistics truck many years before, and it's completely autonomous truck which can have logistics from one place to another place without having any kind of human drivers. And robotaxis and Waymo, and other. And now we have Emirates is planning to build drones. Airbus is working on building the autonomous aircrafts, commercial aircrafts. So which is a dream actually, to have an aircraft where there is no pilot and there is no captain. It flies itself. So it sounds very scary, but this is a dream they are doing, and it's under the research and development phase. And MIT has already built smart boats, autonomous boats, and they have done some kind of pilot for that. And delivery and this kind of things, these are all becoming the reality, and this is not the sci-fi. So in Saudi Arabia also, I have seen some of the companies, delivery companies, so they are trying to get the license for home delivery by the drones. In UAE, they have already got a license. I think Kita company so basically one subsidiary of Chinese, Meituan company, so they have got a license to deliver food in Dubai by the drones. So the concept of connected and autonomous vehicle is basically not new. If you were born in maybe 70s or maybe 80s, so you must have watched action drama series Knight Rider that was telecasted in the US in 1982 until 1986, where there used to be a car driven by this guy, which is, this guy is Michael. He has a KITT car, and this car was a semi-autonomous car, used to be driven itself, and there was no driver. It used to speak with the driver, and it was a dream at that time. Can you imagine 1982, we have Commodore computers, or we have very limited computational power. We can never thought about car which is self-driven. And that time, 40 years back, they were showing this kind of technology. So there would be in the future that you have the car which has the artificial intelligence system, which is connected, which can speak, and which can protect the person, of the driver or maybe the person who is sitting in the car. So that was a dream at that time. When I was a small, even I was born at that time, So I watched this drama, in 90s. So I was surprised that, is it possible? But it is possible now. So what exactly is basically, a smart car, or you can say connected vehicle, is basically a computer-controlled and connected vehicle that has the capability of sensing its environment, because it has a lot of sensors, like you can see here. It has LiDARs, radars, and GPS systems, And it has a lot of sensors, ultrasonic sensors, and it has a central computer which is getting all the data from those sensors and processing the data and driving the car itself. So this was basically published by Economics almost 15 to 20 years back to give you an idea of how the future cars will look like. And there was a work which we did a few years back, and we did a survey and published a paper also in IEEE Consumer Electronics magazine that how would be the future of, you know, hello? Yeah. So in 2017, there was only 54 billion US dollar was the market size for the you know, connected and autonomous vehicles. And only in 5 years, 5 to 6 years, we have seen you know, exponential growth. Almost $500 billion US is the industry for this, and it's going to become more and more. And only, you know, like 6 million units were available for autonomous vehicles, and that was 6.6 million, but in 2027, it's going to be 67.5 million. So this is a study which we conducted a couple of years before to show the market trends and the predictions about the future of this business avenue. So when you talk about an connected and autonomous vehicle, it looks very simple that it has a Wi-Fi or 4G, 5G connectivity, but it's not that simple, you know. It is, you can say, culmination of so many systems working in a car central computer. That is maybe artificial intelligence is working behind that, machine learning, and there are so many sensors, actuators embedded on the car. And of course, the backbone is there for the communication, mobile applications, blockchain, and cloud, of course, which is in the background. So according to Intel, a few years back, they predicted that a modern vehicle will be going to generate 4 terabytes of data in 1 hour. My hard disk is 1 terabyte, and it is half empty for last 6-7 years. But a car which is connected with the hyperconnectivity is going to generate 4 terabytes of data. This is the estimation of Intel. So I don't know how you will handle this data, how super connectivity you would need for transferring this data, and where this data will go, and who would be using this data for doing what against you. So this is, you know, sometimes make me scary also being a cybersecurity professional. And today's modern vehicle, we can say that the vehicles which we have, you know, in our use have more than 200 million lines of code. Can you imagine that the Facebook total has 100 million lines of code? But when you build a car, then it has 200 million lines of code. This is a normal, regular car. But once we are going more forward and building more, you know, you can say, stronger cars with the level 5, which I'm going to discuss, then how many millions lines of code you will have to build a car? It's more than, you know, Boeing 787 aircraft. It's more than F-16, you know, and it's for line of code. So the software is eating the world. So this is a very famous phrase, you know. But now, because we say that AI is eating the software and everything. So to build a car, it is the embedded system with the software, with the application, with the ecosystem, and with the vehicle-to-everything communication. So this is going to become a very big, you know, challenge for the cybersecurity researchers to build a secure and resilient vehicle which is free from different types of attacks and vulnerabilities. Like I mentioned earlier, that autonomous vehicle ecosystem is mushrooming. There are a lot of companies in the world. They are coming up with different business models, especially for software, hardware, analytics, you know, communication, and they are building some kind of public, you know, entertainment system, infotainment systems for the public so that they can enjoy. And you have a screen, touch screen, you know, where you can speak with your car. You can order your car to whatever, you know, you want to, like we have seen in the Knight Rider, you know, 40 years back. So I think this kind of technology is giving impetus to build different kind of business models to, you know, develop this kind of cars. So before we understand the different, you know, aspects of the connected vehicles, we need to understand how many levels are there for building a car, a smart car. So Society of Automotive Engineers from the US, so they have actually categorized 6 different levels of vehicle automation, it starts from 0 to 5. So 0 to 3 is basically those kind of vehicles which need human supervision. The cars which we have in our homes, except the Tesla one, if you have, somebody has. So this is basically either from, they start from 0 or 1 or 2. So 0 is that kind of car which does not have any kind of automation, which is driven by driver completely, and their supervision is always required. And there are some kind of cars in the level 1 which have some kind of assistance for cruise control and steering and this kind of thing when you are running on the highway. And it means that you can have your hands-on actually on the steering, and maybe you can just sit and see that what's going on, car is driving itself. And then you have level 2 car, in which you can have like hands-off. You can just leave your hands and car is driving itself, And sometimes you would need supervision when it would be required. For example, you have to turn or something, you want to do something, turn around. So you, of course, need some kind of supervision. But here it starts the level 3 to level 5, which is machine supervision. Here is artificial intelligence, machine automation is coming. So here, for example, if you are driving Tesla X, so you are at the level 3. Okay, so vehicle is in the full control. Sometimes you tell the vehicle that I want to go here, so it is driving itself, and it's taking you. You can close your eyes, and then you can sleep even also, so it does not matter. And then when you talk about the level 4, which is, of course, high automation in the vehicles, in which vehicle will take care of your whole trip, and you can have your minds off even also. It does not matter. So your mind is off, and car is driving you to the destination. And the most interesting is the level 5, that is full automation. That is basically a concept. It does not happen now. It does not exist because it is very, very difficult, not only because of the technology, but because of the regulations and the infrastructure we have around us. So in which there is no driver. So I'm going to show you here how it would look like at a glimpse. So of course, we know all the levels we have seen. But the interesting one is this one, the level 5 car, which is a concept car. There is, in the cockpit, there is no steering. There is no brake, there is nothing. There is only screen, smart screen, and there is no driver. You just sit there and talk to the car, and then do whatever you want. So it's more connected, more intelligent, but it's in the concept now. Even the Tesla and many companies are working in the background, But of course, to have this kind of car, you need a lot of efforts, not only for the technology, like I mentioned, it's infrastructure, and the regulations and policy. So here are those challenges which I was discussing earlier. So to roll out this kind of cars, it's not easy in every environment because some of the countries where there is no smart infrastructure. So there is no lanes, for example, for driving the car. So if you ask Tesla to drive the car without the lane, so it will mix up. So that is a big problem. And another problem I tell you, it's a funny story. A few months back, one guy in the US, he wore a T-shirt with a stop sign on his shirt. And he stood on the street, and when the Waymo was coming, a robotaxi, it stopped. It thought that this is a stop signal or stop sign, but it was actually wore on the shirt of a person. So it does not recognize the environment. So that is, technology failed there. Sometimes technology, fails because of some silly things which the designers or the developers or the engineers who are building the technology, they never care of. So this was unfortunate. So there are so many these kind of incidents which are happening. And I'm going to show you one of the things which actually recently happened because of the signal jamming. The camouflage of the signals, for the autonomous vehicle, that is going to be devastating while the car is driving at the speed of 120 kilometers per hour. So, like I mentioned, that the infrastructure we have, the road regulations, the safety policy, environmental insurance liabilities, and testing of the CAVs, and talking about the social impact and regulation, standardization. These are very, very big challenges. Because the manufacturers, they want to push their products to the market without having these things into the consideration that what would be the consequences on our society, and are we ready for the this kind of adaptation of this kind of technologies? So that comes a big problem and dilemma. And another aspect is the ethics for the CAVs. For example, you are talking about an autonomous vehicle, it is driving. So when there is an incident to be happened, so who should be killed, the pedestrian or the driver? So there has been a lot of debate on that. Mercedes says that we would save our driver. We would not save the pedestrian. But there is a lot of debate that you should save the pedestrian, not the driver, when you have to collide. So this kind of ethics issues are becoming a cornerstone for the policy, and we need to address them. And there is, of course, data and privacy. When we talk about 4 terabytes of data, just 1 hour. They say per day, but in the future it will be 1 hour per 4 terabyte of data. So what would you do with this data? So what kind of concerns you would harness because of that? And of course, the cybersecurity, that is more about protecting your whole infrastructure, not only the car, but the infrastructure of Tesla or other manufacturers or other car service providers. Because sometimes you are very safe and resilient. You have state-of-the-art infrastructure, but supply chain attacks are coming from different vendors, and they can lead to the compromise of your whole ecosystem while you have with you. So I think this is very important to address if we want to protect the whole ecosystem and have a resilience into our vehicles. So the cybersecurity of the CAVs is basically an exploitation of the vulnerabilities which any car or any vehicle can have in their systems, hardware, communications, or any kind of maybe applications they are running. So we must know that in 2015, when 2 black hat hackers, so they compromised the security of Jeep Cherokee. So they were able to control the car while they were not in the car. So they were sitting remotely somewhere, and this car was able to be controlled by the hackers. They can control the speed, they can turn on the infotainment system just by having some kind of vulnerability exploitation in the cars. And there have been so many news in the media about the compromise of these kind of vehicles and what would be the consequences, and especially when we are talking about the cyber crimes. And if some special or VIP personality has to be attacked. So this kind of systems can be compromised, and anybody can do anything, which we have seen that small pagers which were exploded few months back in the region. So this kind of things, when they have a lot of connectivity, so any vulnerability can be kept by the hackers, and they can be harnessed when the time comes in. And the good thing here is opportunity for us is the automotive cybersecurity market is increasing exponentially, which is going to become almost $8.6 billion by 2027. And here is the opportunity for young entrepreneurs, or maybe us as a faculty, if you want to establish your business or startups, so you can just go and further explore in your specific area. And cybersecurity of actually autonomous vehicles is very, very complex in a terms that because we have more than 200 to 250 electronic control units, ECUs on the car. So electronic control units means the sensors, actuators which are controlling the cars, for example, lock system, brake system, and engine control system, and so on and so forth. And there is a CAN bus. CAN is basically a protocol which is used for the communication in the vehicle. For example, it is called controller area network, like we have local area network, wide area network, so it's a controller area network for the car. And we have numerous attack vectors which are known and which are unknown actually also. Because if you are talking about APTs, advanced persistent threats, of course nobody knows the 0 days. Anything can happen any day. Anybody exploits the vulnerability and then can compromise the security. And of course, we have the hyperconnectivity, vehicle to everything communication. So here is a channel for hackers to penetrate into our systems and compromise the security. And of course, we have different types of risks which are related to the physical risk and network attacks and road infrastructure attacks and so on and so forth. So you can see here, this is a car which is, I would say, systems of system. Like there are a lot of systems in the car. We have more than 200 electronic control units here. And we have infotainment system, which is actually a very good, you can say, target point for the hackers to penetrate into the cars. And that was basically a focal point for Jeep Cherokee to be hacked 10 years back. And still, we have this problem in the cars. And then we have back-end servers which are running in the cloud, maybe somewhere, from the automotive manufacturers. Then we have, different communication channels. And we have onboard systems also, different kind of systems. So there could be a possibility for the hackers to penetrate into your car by the physical attacks or by the network kind of attacks. So it depends, And especially when we talk about the physical attacks, so physical attacks could be ignited by having the side channel attacks, or there is one possibility of the supply chain attack, which is becoming a very big threat for the whole global world. Like we say, the ransomware is a cybersecurity challenge and threat for the whole world. Similarly, we have the supply chain attack. For example, because like for example, the mobile phone which you have in your pocket is not built by Apple, Apple phone if you are talking about. It is made in China, for example, designed in the US, California, and China is buying a lot of hardware from different vendors, and just trying to put on the board. So if there is any kind of vulnerability in any component, and there is a backdoor, which would be included in the whole product, and then hackers will exploit that vulnerability to launch supply chain attack into your system. So, and this is very common, like we have SolarWinds, in the US, and few months back we have the blue screen, in the airports. Everybody was sitting at the airport for hours and hours, and we have the blue screens and nobody was working, no aircrafts can fly. Because of that, that was an attack of supply chain attack, that was launched on the Microsoft systems by the hackers, and they had the vulnerability into one subcontractor, and they, just penetrated into the whole network and compromised the security. So the controller area network is basically, you can say it's analogous to the human nervous system. We have different veins, we have our own nervous system to send the signals from our brain to different parts of the body. Similarly, we use the canvas to send the signal from one part to another part. Once, for example, you press the button to open the lock, so the signal is sent to the ECU, and that ECU, which is specifically focused on open or close the door of the your car, so that works, and that sends a signal on the canvas, and then in response, that actuator actually opens or closes the door. So canvas is very complicated, and this protocol was developed almost 80 years back by Robert Bosch. Bosch is a very famous company from Germany, and unfortunately, like the OT systems, we are still using the same kind of protocol after 40 years. Everything has changed. Computers have changed. Computers have come into our pockets, from the tables and from the rooms. But still, the protocol and the buses, we are using the same thing. It has never been changed, and that is the point for the communication security vulnerabilities, for the hackers, especially when we talk about the intra-vehicle communications. So if you have, for example, some kind of devices you inject onto your own onboard system, so you can start scanning all the onboard systems on your car, and you can see that which onboard system is having some kind of vulnerability, and then you can launch an attack on that system, and you can compromise the security. For example, if you are talking about some kind of mission-critical system, like braking or engine, so that is very dangerous for any car. And frankly speaking, because of course sometimes we do not quote in the public, and public forums. So there are so many, famous vendors. They have a lot of vulnerabilities into their system, which we have been compromised. Even some IoT devices from some companies which are available, you are using maybe in your home, by doing some kind of offensive research in our labs. So we have compromised the security. But of course, we cannot reveal that in public. And like I was mentioning earlier, the use cases for the communication in the vehicles are very, very complicated. And they are becoming more complicated now, because before we had only vehicle-to-vehicle communication or vehicle-to-infrastructure communication. That was the 2 or 3 cases. But now we are talking about vehicle-to-pedestrian communication, vehicle-to-grid communication, and you're talking about network communication and everything, cloud communication. So that is becoming a very, very, complicated problem for the researchers to solve, because everywhere there is a communication between 2 devices and 2 systems. So of course, security has to be inculcated by design. So this is the important thing. Security by design is the most important thing, because we do not do the security after we build the system, but we do the security before we build the system, when we are on the paper, designing the system, for example, or in the computer. So some of the works like we have been doing in this domain is one of the projects which we got a funding from the Ministry of Education, a few years back, to develop some kind of protection layers for the autonomous vehicles. So this is basically a very interesting project. I would explain you first the preamble of this project, then we'll go into a discussion. So when you go to buy some products like refrigerators or microwave, so there are labels. Have you seen the labels green and red or yellow by the energy and these kind of things? So we have never seen this kind of labeling stuff in the security, while we have for sustainability. So we build a labeling system for the security also to have some kind of trust for the people who are using the technology. The problem with the technology is that you do not trust. For example, if I ask you in this hall, how many of you sitting in this room will be liking to sit in the autonomous vehicle? Only maybe 1 or 2, 3, 4, but most of you are afraid. You do not know, because it is not in your control while you're driving. And you have seen Tesla, had a lot of accidents when it was driving at the speed of 200 kilometers in China. Have you seen that devastating, which is crushed, several people, there? Because driver says that I cannot control the car. It's of course, driver was saved, but the people or pedestrians were killed. I think more than 10 people. So he says that, and there is no liability on his shoulder, by the way, because he's not the driver. The car is driven by the automotive system. So this is another policy issue. So how to solve this thing? So who will be the liable? The company will be liable, or the driver will be liable? So nobody knows the answer for this thing yet. And so we gave the concept of labeling into the vehicle system, that users should know that what is the level of my security in the car. For example, when you talk about the over-the-air updates of the software, like you get your mobile phone updated all the time, or your applications, they keep updating themselves to protect you from different kind of vulnerabilities. So similarly, we should have some kind of protocol and some kind of system into our modern vehicles, which give us the provision to control the over-the-air updates, whenever they want and whenever they are, and whenever they are pushed by the manufacturer. So we should know that what is going on, because sometimes there are some kind of injection attacks which can be injected by the hackers while you are trying to update your systems. So that is one of the vulnerabilities. So in this, we actually build a cybersecurity box. That is basically a system which can be integrated into the smart vehicle, and that is connected with all the ECUs, 250 ECUs, and with the manufacturing server, like the car manufacturer, like Tesla or Waymo or whatever you are using. And that basically is giving you an insight whenever there is a kind of update happening on your car. So you will get on the dashboard of the screen that this kind of updates have been done, and it was done by this date, and from which company it was coming. For example, you are using infotainment system, which is built by some other American company, let's say, and the car is coming from Japan or China or from Korea or even from Saudi Arabia, like we have Sear Motors here. So you have to know that, what kind of systems are being updated. So in other words, we said user-centric security, which is a new, which of course, we would not say new, but which is a new in a sense that user wants to have security in his control. User wants to know that what is happening with his devices, right? So it's called user-centric security. So this is more inclined towards the user-centric security, in which we have built this system, CS box, which is basically a central, into the, you can say the ECUs, which have been deployed in the car. And it has 3 units, which is, number 1 is the data aggregator, which collects all the data from the different ECUs, and which checks that any ECU requires some kind of updates. Then, it tells the consumer that there is an update, coming out from the automotive manufacturer, and you need to update it. And there is data analyzer, which is analyzing the data in all over the car, and checking it and keeping tracking of all the updates. And of course, there is a CPU. And this system is connected with all the, through the Ethernet, which is CAN bus on the car. And this system actually we got developed also, and we are now in the phase of licensing this technology to a South Korean company. So we are negotiating about licensing this technology. Even we talked to the Sear Motors also, but Sear Motor, is a Saudi-made company, but still, they are struggling to do their own R&D. And of course, this was patented technology, which has got patent in the US Patent Office and in the Saudi Patent Office also. And another concept we gave in the motor vehicle cyber inspection. You have in Saudi Arabia we have Fahas Dori, right? Every year 2-3 years we have to renew our Fahas. We go to some workshop, and they check the maintenance of our car. So it is maintained. There is no any kind of some kind of vulnerability, for example, in terms of hardware and whatever. Similarly, we gave a concept of motor vehicle cyber inspection. MVPI was here, motor vehicle periodic inspection. We gave the concept of motor vehicle cyber inspection. Because the problem is with the cars is that there is any kind of vulnerability could happen, and it's not going to compromise the life of the driver. It is going to compromise the life of many people in the road and pedestrians. So we need to also have periodic inspection of our cars, and we should have the reports generated by the cars, which should be shared with the regulatory bodies, for example, or even for your own self. So this concept was basically done while you go for the charging station to charge your car. It usually takes 20 minutes, for any car like modern car, 20 to 40 minutes to charge. So while the car is being charged, so you can have automated system which can scan the vulnerabilities of your whole computer. Computer, when I say computer, so we say computers in wheels. So that is basically the automotive, modern automotives. So it can scan all the vulnerabilities. Is there a ransomware attack kind of thing happening? There is some kind of loophole, or there is some malware, which is trying to penetrate into your system, and it would generate the report on your dashboard, and then the driver will feel safe. So what is the reason for doing this thing? The reason is the trust. Because the trust is the most important factor which drives the buying of the consumers. You would never, for example, if I asked you that, would you put a CCTV camera in your bedroom? Nobody would do this thing. Because you do not trust this camera maybe is streaming the video to anywhere in the world. And while there are so many applications, you can watch CCTV videos of many people around the world in their homes. So because of the compromise, and we have known the Mirai botnet, which can easily compromise the, a lot of hardware, connected devices. So that is a big problem here. So the concept here is that you go to the charging station, you plug in the car, the system basically which we have developed, which is scan the car vulnerabilities with the different vendors, the set of the vendors are there. Of course, this is a business model. Then you will select the, for example, you want it to be scanned by Trend Micro or Kaspersky or whatever, and then it would scan whole of your car, all the ECUs, and then it would generate the report and would be displayed on the dashboard of the consumer, of the user of that car. So this technology also we got patented just recently, and we got an innovation award also for Geneva Expo, and we are going to license this technology. And we are in the negotiation with the Sierra Motors if they are interested in this technology. But I have already got an interest from South Korean company who wants to take this technology. And fortunately, this got a lot of media attention also in Arab news, and many newspapers covered this because this was a breakthrough. It never happened before this technology, in the automotive sector. And there is another aspect of the trust, like we were mentioning. Trust drives the buying of any consumer for anything, especially when we talk about the connected systems. So we actually gave a model for trust that why trust is important. Trust is important for the security of your device, at the system level, security of your applications, and security of your communication. So all of the things, if you have privacy, security, for the device security, then it would motivate you. It would give you a feeling that, the product which I am using is basically trustworthy. So I should go ahead and take the next step to buy it. Otherwise, of course, you are going to compromise the trust, and then you are going to lose the market. And that is the big problem with the IoT. Like the promise IoT did 50 billion connected devices, by 2020, like Cisco predicted in 2014. Why we did not achieve that, The reason was because of the trust. Many people do not trust the IoT devices. They feel that it is very dangerous for us, So another problem is that when you have the 4 terabytes of data for, your car every hour, let's say one day, where is this data going? So what is this data, what is this, where is this data going, Who is using my data? And when my data would be generated from the car, and with whom this data would be shared. So there are a lot of privacy concerns, people have in the modern vehicles and IoT systems. So in a sense that if you want to have a more trustworthy environment, you should have the knowledge and you should have the control of your data. Because data is the new oil, like we say, and data monetization is the new business model. This is where many companies are becoming, unicorns and making tons of money. You see all the social media companies, why they are unicorns and why they are, like the big tech giants and conglomerate, so why they are? Because of the data. So similarly here, the data is the opportunity for many companies, many vendors. But for us, it is very important. Why should my manufacturer know that where I am, what I am doing, what I am talking in the car? They would also know this thing that while you are speaking, on the car, so because there are sensors and there are, microphones which is recording, maybe they are sending the data. And so how can you know, and there is another debate, recently going on with the Ford Motors that I think there is a case filing against them because there was some kind of privacy compromise of the user's data for the connected vehicles. So maybe you can explore it more in the news media. And taking you to another side of the railway systems, because railway is also connected and becoming autonomous systems. So I got a funding from National Science Foundation of China in collaboration as a foreign expert. So we were actually given a project to secure the connected railway systems and autonomous railway systems. So because China has a very long, railway track, which is almost estimated to 150,000 kilometers, in the whole country. And they have high-speed trains also, and now they are building autonomous trains. And the railway systems are very, very complicated. Why? Because they have a lot of turnarounds, they have gates, there are some circuits, and signals also there. So anything, of course, which is converging the IT with the OT, then it means that you are giving opportunity for the nefarious actors to come into your system and compromise the security. And this has to happen, not today, maybe tomorrow or day after tomorrow. You have to connect the systems, you have to connect your industries with the IT technologies. So similarly, here we have a problem. So if you will give connectivity to all these signals and turnouts and everything, then hackers can compromise. So we actually got a funding to build very lightweight kind of authentication, inside the railway communication system, so that they can easily communicate, and that should be reliable, faster, and more efficient. So, for example, you can see here that railway infrastructure has a lot of locomotive track signaling, which we already discussed, and there are some different kind of dedicated networks, IoT networks or mobile networks. And then we have integrated data center, because all the data which is coming out of the train, it is being sent out to the integrated data center, which is collecting the data about the frequencies, about the speed, velocity of the train and everything. And then there is a railway cloud computing. I don't know maybe if you have heard of cloud computing. Everybody knows the railway cloud computing, the back-end servers which are processing the data. Because you're talking about a country like China, which has high-speed trains and so many trains, high-speed trains, running, and all the data coming from different parts of the different cities or different, counties. It is being sent to the Beijing, and then they are processing this data. So to have this kind of data, to make the data analytics out of this, and to make the decisions, feature extraction from that data, it is really cumbersome job. It's not very easy. And then the applications which are running out for the users and for the operators who are running the systems. So that is also very complicated. So this project was successfully delivered to National Science Foundation of China, and we also have some kind of technology adoption from a vendor in China. Then we have space ground integrated autonomous railway network security, because one of the problems which we have in this kind of systems is that they are software defined. Okay, very good, very fancy. But another thing is that the authentication. While you are moving from base station to base station, different networks, so you have two types of authentication. Initial authentication, which is done from the base station, then you are doing the handoff authentication while train is moving from one base station to another one, and so on and so forth, because it's a long distance, 1,500 kilometers. So in this kind of challenging situation, how will you build the authentication? And frankly speaking, like Bruce Schneier, if you are familiar with security guys, Bruce, and I also agree with him that authentication is going to fail. And that is very dangerous for our ecosystem, because authentication, we say, is the first line of defense against the cyber attacks. If authentication is failed, then all the security is compromised. And that is the problem here which is happening, that because you have hyperconnectivity with everything, and then everything has to authenticate with every other thing. And sometimes it's ad hoc, sometimes it is fixed. So in this kind of situation, your devices, with the computational power, with efficiency, with the compromise of any kind of supply chain attack or any kind of system, even one system, it would compromise the whole ecosystem. And another problem is how to build those lightweight and efficient authentication protocols into that kind of tiny and very resource-constrained system. So that is another challenge for us, being security researchers. So we did some work, and we got very good performance in terms of communication delay and overhead. So, and maybe this paper is available here, just recently published, so maybe if you have interest, so you just browse this paper. and see. And there are many more contributions which we are publishing in TIFFs, for example, the top transaction in security, and VT, and ITS, and so many other papers which are in the pipeline, and research which is coming out. So not we do the academic research only, but we also focus on the licensing of the technology, industrialization of the technology which we do in our center. So what are the challenges and the future directions in this area, especially for those who are entrepreneur enthusiasts or research enthusiasts? So the first, like I was mentioning earlier, is the adversarial signal jamming and DDoS attack. You have state-of-the-art security, you have state-of-the-art systems embedded onto your vehicle. But if you can compromise the jamming, or you can perform some kind of adversarial signal jamming of that machine which is running on the street, then that machine is no use. It can do anything. It can actually hit to the wall, or it can hit anybody. That is a very big problem. So how to make them resilient in this kind of situation while a DDoS attack, distributed denial of service attack, is launched on them, so they can behave perfectly. So they should come to separate mode. So here is a mode actually, a safe mode. Like we say in computer, we used to have safe mode. So here we have to build some kind of safe mode. So once the car feels that there is some kind of vulnerability or attack happening on me, so I would turn to the safe mode. But unfortunately, it does not happen. And then we have, like I mentioned earlier, V2X authentication is going to fail because everything is, you have to authenticate with everything and every time. How can this be possible, with the processing limitation and connectivity? And ransomware and malware. So there is a problem. Once you get up in the morning, go to your car, there is a screen saying that your car has been compromised. So pay 0.01 Bitcoin to get back your car. It's a ransomware attack on your car. It's possible, You have the ransomware on your computers. You will have ransomware for your vehicles also in the future, because they are using Windows system, for example, or maybe some kind of other systems, right? Then the incident response and handling. IR is a big problem. We have the problem for the IR, We do not have the capacity for doing IR in our organizations, While you're talking about, vehicles, so who would be dealing with the incident response and handling of the vehicles if they get compromised? So where would you take your car? Not everything you can do over the air with your car manufacturer. Maybe you have to take it to service station, But who would be doing this thing? We do not have this solution yet. Data privacy consideration, which we have discussed earlier, that data is, a big trouble for us in the privacy. Supply chain attack, we discuss a lot that any kind of hardware vulnerabilities which is coming from your subcontractors or manufacturers, and there is any kind of loopholes, so of course it is going to have serious ramifications on your system. And there is another problem, because usually we ignore it. That is about the lifetime of firmware patches and updates. For example, you are using refrigerator or old television, which is very classical. You have been using it for 20 years, 30 years, nobody cares. The vehicles you have, nobody cares. But what about those systems, which you are building for over-the-air update, all the time you have to keep updating them. So the manufacturers, how many years manufacturers will be building the patches of firmware for them? This is another question, sir. How many years, manufacturers promise you for your car? Anybody knows? 10 years maximum. But the normal car, you can drive, maybe 2007 Honda Accord, for example, you can drive until now. Nobody cares because you just, no need to update over the air. But the manufacturers will stop making the patches and software update. And that is basically a vulnerable point for you, because if your car would not be updated by the security, then there could be some kind of serious ramification, And of course, auto industry bug bounty and vulnerability disclosure program is very, very important for the vehicle manufacturers. And they are trying to adopt this philosophy. And I saw Tesla and some other manufacturers, they are doing bug bounty programs and inviting ethical hackers and penetration testers to test their system, because it is called open innovation. You do not have all the best experts working in your company, but there are so many experts, hackers who are sitting around the world, so they would hack into your system ethically, and they would tell you the vulnerabilities, and then the manufacturers will fill that vulnerability. For example, I know a guy, he just got $100,000 US, for identifying one vulnerability in Apple system. Hacker, ethical hacker. And up to 1 million Apple is paying for one bug bounty, $1 million to identify one vulnerabilities. People are becoming rich and rich, and they are geeks, just undergrad students, they are making tons of money out of that. So the problem with the cybersecurity is this, it's like an iceberg. So what we know is just the tip of the iceberg, and what we do not know is the actual iceberg, which is hidden from us and analogous to the actual iceberg within the water. So unfortunately, this is have been talking this thing for last 2-3 decades, and we will be continuing talking this thing. So it's a kind of Tom and Jerry, cat and mouse game between the hackers and the people who are defending the system. So thank you very much for your attention. If you have any questions, please feel free to ask. Thank you.
Thank you, Professor Khurram, for a very nice and thought-provoking talk on cybersecurity of hyper-connected world and autonomous vehicles. Sure, like indeed, without security considerations, technology cannot grow. So if you have any questions, please feel free to ask.
Hi. So my question is regarding you talk about the motor vehicle security inspection. What about the intervehicular communication and the privacy concerns regarding different service providers? Thanks.
Intervehicle or intravehicle?
Intervehicle.
Yeah, of course, like I mentioned, V2X communication is basically, intervehicle communication, because vehicle has to communicate ad hocly with other vehicles also, right? With the infrastructure, with the telecom operators, with the pedestrians also. In the future, you will have receiving the messages on your phone that the cars are coming, for example, and the grid also, right? So of course, all the communication use cases have different types of communication gaps, especially when you talk about the authentication. It's a very, very terrible, very, very difficult also, because one if key is compromised, and because you have to use symmetric key encryption in this, right? And then it will compromise the whole ecosystem. So that is one of the challenges for the intervehicle communication with the environment, with the ecosystem you have, right? And other kind of challenges, like I mentioned, is mostly coming from the like the supply chain, because what frightens me as a security specialist, whatever, the incident of the that pagers which had happened recently, 2-3 months back. That is a frightening thing. That is a supply chain attack. Have you heard about that thing?
Yes.
How many people know, right? You know already. So this can happen with anything.
So will the service providers be able to reach on consensus regarding providing the security? Because it is not possible that everyone will provide the data that is concerned with their users.
User is a victim, that is a problem always. User is a user, and user is a victim also. So, for example, the Tesla compromise which had happened, in China. So it killed 10 people, right? And nobody takes the liability. Have you seen the Tesla says, we are not liable for this thing. And the driver says, I'm not liable. So who is the liable? And the compromise of the life of the 10 people, So that is another problem. So there's a very big policy issue. Standardization is important. We have very less standards. ITU efforts, IEEE efforts, because I am doing standardization also, working with IEEE and ITU. So I know that there is very less standardization efforts for this thing. They are doing, but it's not enough. And there are many other problems with the vendors. Vendors have their own, thinking. So they want to, like some of the giants, tech giants. So they think that they are the best, some other vendors from rest of the world. So they have their own philosophy. But of course, there are some regulations. There are some standards, for example, ISO 24001, what is the standard for, I forgot, coming out of my mind, ISO for the vehicles. And there is our United Nations, 155, 156 standard. So there are standards, but still they are not enough, because these were built for the classical systems. Now we have very advanced, sophisticated systems. So that is becoming a big challenge.
Thanks.
Thank you, Professor Khurram. So basically now we have coffee break session. So if you have any further questions, you can please interact with Professor Mohammed outside during coffee break. So we will be having very interesting panel on security and privacy of Next G after coffee break. So let's meet again after 20 minutes. Thank you.
Right, okay. Assalamu alaikum wa rahmatullah. Good morning, everyone, and welcome to this panel, which is the second panel in this summit. The title of this panel, as you can see on the screen, is Security and Privacy Requirements and Challenges for the Next G. We're absolutely delighted to have our panelists here. I'll start by introducing them, and then we move on to a few topics that we will discuss. Towards the end, we will open the floor to questions or maybe contributions to the audience. However, if anyone has any burning question or comment that cannot wait, we are very happy to take that as well. So please just raise your hand and we will accommodate that. Sitting next to me, Professor Mohammed Hamouda, and he's the Saudi Aramco Chair Professor of Cybersecurity. His research interests are around the applications of Zero Trust Security Complex, highly decentralized systems. Recently, his research shifted towards computer or quantum technologies, specifically post-computing and cryptography and quantum readiness. Mohammed advised the UK's government on law reform related to national cybersecurity through a number of committees and hearings. I've had the pleasure of working with Professor Mohammed in the UK and also here now, so he's been a good friend as well as mentor. Next to him, Professor Mohammed Khan, was a professor of cybersecurity at King Saud University in Riyadh, and he's the founder and CEO of the Global Foundation for Cyber Studies and Research in the US. He's the editor-in-chief of Telecommunication Systems, and also an area editor of cybersecurity and IEEE communications and communications surveys and tutorials, and an associate editor of quite a few IEEE journals and transactions. He authored over 500 research papers, and he's a fellow of the IET, which is in the UK, and a fellow of the British Computer Society. Next to him, Hussein joined us on this panel, coming from a slightly different background, working in industry. And interestingly, he was a graduate of KFUPM as well in 2001. So some background about Hussein: he has over 20 years of hands-on experience in software engineering. And also he had a few posts as a leader of IT section, information protection, and application management. He's a co-founder and the head of Digital Safety Club under the Howie program. And he has 2 patents in the area of cybersecurity. So I'd like to welcome you all. Thank you for joining us. I'll start with my first topic, or the question. So what roles do you think academic institutions are playing in the kingdom in bridging the gap between industry and government when it comes to securing the next generation of systems and the overall cybersecurity landscape? I think we will have different opinions on this, maybe some coming from academic background, and then maybe Hussein will give us what they think from their perspective in industry. So we'll start with Professor Mohammed Hamouda. Please, over to you.
Okay. Thank you, Khalid. So this, I think the straightforward answer to this question is, first of all, talent development. So this is what universities are usually good at, producing highly skilled cybersecurity experts. But also research and innovation. And if you consider the pace of cybersecurity and the incredibly changing threat landscape, I think research and innovation is the answer. So universities, they can, or academia in general, they can contribute significantly by producing applied research, but that cannot be done without the involvement of the industry, and that's where people like Hussein comes in to give us their pains, to give us their, since we're talking about the next G, the next generation of problems that they would expect with emerging technologies. So working with the industry is extremely important, and both of these, they are aligned, well aligned actually, with the government's 2030 vision of investing in the human capital. And there is a lot of stress on developing in-house expertise, in-house products, and the kingdom now officially they want to diversify their technologies, their portfolios, their solutions, and they're looking to become a leader, not just a consumer of technology. And I think academia is the powerhouse to produce the skills and the innovations that helps in achieving that aim.
Right. Thank you very much. Professor Muhammad Khan, what's your thoughts on this?
Thank you very much, Dr. Khalid, for this great question. As Dr. Muhammad says, Professor Muhammad says that the human capital development is imperative for the nation building, and this is basically where the Vision 2030 actually comes forward. So before I answer this question, let me take you back to 2012, when the incident of Saudi Aramco happened, in 2012 in August. So that was basically a turning point for the kingdom to invest into the human capital building in cybersecurity specifically. So the government actually reached out to the universities like ourselves in KSU, and they asked us that what local capacity do we have if such kind of incident happen again, unfortunately. So how can we deal with this kind of situation? So the first answer was, of course, human capital and capacity development. So universities were asked, not the KSU, but all the universities in the kingdom, to develop the programs, to build the talent pipeline for the future generations. So that was one thing. And the second thing was, of course, Vision was launched in 2016, so after a few years. So that became a kind of exponential, vehicle for the, Vision to carry forward and build different types of programs. And one of the programs which I would like to mention is called Human Capital Development Program, which was launched by Saudi government a few years back, in which they want to build the capacity of the kingdom in different areas, not only in cybersecurity, in technology, in policy, in, for example, in natural sciences, also physics, chemistry, biology, and so on and so forth. So this is very, very, like comprehensive and holistic vision. So this is number second. The number third is about the research and innovation, because the research which we are conducting in our labs, in our centers, so this is not just for the sake of archiving, publishing papers, It should be reduced to the, technology development, licensing, also, or commercialization. Or sometimes it is not necessary that you produce that kind of research which makes the money, which makes the impact on society. So there could be some kind of research which is for non-profit sectors, but it is making impact on our society, So that is also one of the aspects which has been usually, unfortunately neglected earlier, but now we are trying to overcome this also. And the fourth dimension which I would see is that there is a demand of 4 million cybersecurity jobs, experts in the world, according to ISS Square, And it was estimated many years before. And we do not have the skill set available for cybersecurity. The problem with the cybersecurity domain is that it changes overnight, because new threat landscape is coming, new vulnerabilities are mushrooming, and new, things are emerging. So how to keep our staff skilled, number one thing. Number second is upskilling them, right? Because you have to upskill your staff, in-house. And then number third is reskilling them, for the new threats and vulnerabilities, and especially when you're talking about AI, which is AI is merging with cybersecurity as a double-edged sword, So we need to see this also. So it's not very easy, it's very competitive, and fortunately Saudi Arabia is doing great in this domain, and we have seen by the ranking, by the parameters, by the indicators, like in the ITU, we are top tier 1 country in the world in the ranking, with the top nations like US or UK. in cybersecurity. So I think this journey is like a decade-long history, because I have been here since 2009, so I have seen all the transformations, from the beginning, how it started, and now where we are standing.
Yeah, thank you very much. I think, Professor Muhammad, you mentioned an important point. The AI, we'll come back to this, the role of AI and how we mitigate issues like that or associated to that. So, Hussein, moving onto you, please. From your perspective, how do you see academic institutions contributing towards that? It could be in terms of the graduates you hire. So what's your thought on that, please?
Well, first, good morning, and thank you, Khalid, and thank you, KFUPM, for having this next G Summit. I believe this is an essential part of trying to cope up with the new security and the new generation and how to protect our technologies. And it is good that you have the academic part and the industrial back or the business view of this. Maybe one of the challenges that we have here in Saudi Arabia, as Dr. Mohammed mentioned, that challenges of coping up with the new technologies when AI comes, or before that, the 4G and 5G and 6G, and it goes on and on. As an employer, when employees come to, we hire people in cybersecurity, and maybe Saudi Arabia started the TWIG program to accelerate having specialized people in cybersecurity. That was a nice program to have. Maybe the quality of the graduate was not up to par, but it was a good starting point. And when we come to the academic, to the universities and how they prepare graduates in cybersecurity, we cannot guarantee 100% that all graduates will be really suited for cybersecurity specialist work. We have, I've been hiring people since 2020 in cybersecurity, and there is an attrition ratio, which is people work with you for a year or two, and then they find another, because there is of the demand, the high demand on cybersecurity. Before they build their skills, they leave. So can academia in general help in that position, or help students understand it's not that this is like the tip of the iceberg? When you see cybersecurity, what you get in academia is just the tip of the iceberg, and that there are layers and layers that you need to learn and get your hands on and get dirty on it. There were cases when graduates with 2 years of experience, but they did not have the passion, that were trying to get a cybersecurity job with us. And there was one who did not have that experience. He just got graduated. When you compare the passion and the achievements, the knowledge they get, it's more coming with passion. The person with the passion had more quality. So we hired the one with zero experience. So academia can play big role when it comes to preparing the hands-on people. If there are workshops, if there are labs, building a honeypot, building things that they get to know what is the real business is. This is, I believe, one of the major achievements that an academia can focus on and be the starting point for having specialized cybersecurity specialists and graduating with knowledge, ready to work, ready for the market, not just a graduate with a cybersecurity certificate.
Yeah, absolutely. Yeah. Thank you very much. So I think this is taking us to the next question here that I have is, what key, let me first ask the audience, does anyone have any burning question or a comment? We have one at the back, maybe we can take this one quickly, please, if...
Okay. My name is Dr. Mahmoud Khassas. I'm from Electrical Engineering Department. But just the last comment came from Aramco. Regarding actually when you said preparation for our student, because I'm in charge with the program and training, I would like really to have kind of scholarship, starting from the freshman year with the student, with cybersecurity. You should be able to interview them. That's what happened in this kind of model in the state. And by the time he reaching the senior years, because every summer he can come or she come and work with you, they can be able to build up slowly. By the time they're graduating, they will be very effectively, and they will be really directly without any training or give them any other things, they will be more excelled for that. This is my comment on that.
Okay, thank you very much. Thank you. That's probably something to consider, I guess.
Yeah, I would say, like, if it was up to me, I would say yes.
Yeah.
But businesses are, they would like to have people ready to work. In our hiring, we have at least a month of preparation. And usually cybersecurity, this is maybe a tip for people who are studying cybersecurity. The first job you get is a SOC analyst, a person who monitors the traffic, who monitors the attacks, and try to kind of see if it is a real threat or a false positive.
Right.
This is the starting point. So this could be done with so many applications now. CTFs, capture the flag competitions. There are multiple websites that they can get cybersecurity students up to speed with what's going on. Co-op or a training is nice to have, but it's not up to me.
Okay. Okay. Yeah, thank you. I think Mohammed, you wanted to add something.
I know you want to move forward, but I think the trend at the moment, with all applied sciences, including cybersecurity, is to run something like we're doing the AMAX here, where students, they will learn on the job. And in the UK, for example, now the shift is towards apprenticeships, and I think there's a similar trend in Germany as well. So in workplace learning, I think is the way forward. And I think KFUPM is doing, started already doing that. Even I think there is plans for the undergraduates, I think, now. So I'll let you move on to the next point, Khaled. I know you were behind.
Yeah, thank you very much for this. So in terms of challenges, what key challenges do you foresee when it comes to protecting the next generation networks? And how are they becoming more challenging for the future? Probably we can start maybe, or maybe you can take a break, I guess, for a minute, and then we come back to you. Unless if you are very passionate and you want to go ahead.
I can maybe, because I already mentioned this, I can add two things. First of all, the changes of the spectrum. As you know, the weakest link in a chain in cybersecurity is a human. So how many people understand that spear phishing is very dangerous? This is when it comes to systems, our specialists, our cybersecurity specialists, they can monitor the systems, but they cannot guarantee that there will be no human mistake. And this is where we started an awareness campaign. Some of the people get fed of it, bored of hearing about phishing email in specific. So we try to become more creative in how we make the awareness about psychology, about human engineering, or what comes to abusing human behavior. This is so the answer is the most challenging is human behavior.
Right, and you expect this to be, to remain the case in the future?
Yes, definitely.
Okay.
Yeah, absolutely. So, because human has always been the weakest link in the chain of security. So the exploitation of the human is the easiest way of bypassing any system. Like you can have authentication bypass, for example, or some kind of links you send to the user, and then he clicks and then he compromises. So of course that is most important thing. So this is from the human-centric cybersecurity. But once we talk about the technology-centric cybersecurity, then the threat landscape is multiplying, because we are giving hyper-connectivity to our systems. Like let's say when we are talking about OT technology, we are converging with the IT. So when you mix the two technologies, which they have their own inherent vulnerabilities, now you are multiplying the vulnerabilities more than that. Okay, then you have vulnerabilities with the connected systems, devices in the back end, then the cloud, then the networks, and you are talking about 6G, and now you are talking about supply chain attacks, and then you are talking about AI systems, and their ethical implications on the systems, and how they would be built, who is building them, what are the algorithms, in the black box, we do not know what's happening in the background.
Mm-hmm. Yeah.
So I think all the things are just multiplying the vulnerabilities and the threats, and creating a new arena for the, like industrial experts, for example, or academic experts also. There is one more point which I just wanted to raise here about when you talk about the academic programs, because like in the universities we teach the breadth of the knowledge in bachelor's. So bachelor's is about the breadth, master's is about the depth, and the PhD is about more specific topic, right? So in bachelor's you have to teach mathematics, and everything to student, and programming. So this is the reason. So they cannot build skills for any specific area as a SOC analyst, for example, or IR person, or any kind of other specialization. So once they go to the field, they have a very good, strong background, for the theoretical background. But they need to get hands-on, to work, and then they get experience, and they do. While hiring the people, of course, everybody has different, aptitude and attitude. So the most important thing, as for me, for example, as a professor, or I'm working with the industry, I would see the attitude of the person.
Right.
If he's a good learner, fast learner, then I will go ahead. I don't care about he does not know anything. But his attitude is for the learning fast and doing fast. So that is the most important thing. Yeah, of course, you can learn anything, very quickly, and there are so many channels available for learning.
Okay, good. Yeah, thank you very much. Mohammed, would you like to add something, or?
I think the biggest challenge is the complexity of the technology. So even if you look at it today, it's a combination of 5G, Internet of Things, edge computing, and we're not even talking about software-defined networking now. We're talking about software-defined everything. And to me, the word software is a synonym for vulnerability. So the complexity of the technology, it makes it very difficult to secure. And the more you combine all of these technologies together, you are expanding the threat landscape. So I have a few other points, but I'll stop here so that we move on to the next topic.
Okay. You actually, Mohammed, something you raised that's not even here. We're expecting to have according to some estimates, over 120 billion devices connected, probably by 2030. How big is this challenge? Or how big is our challenge going to be when it comes to securing such big networks?
In my view, the challenge is not security, is a second-tier problem to me when we're talking about Internet of Things and Internet-connected objects. The first concern to me is safety, because these devices are controlling real-life objects that could have direct implication on our lives, like autonomous vehicles, factories. We're talking about autonomous driving drones. We're talking about autonomous weapons. Imagine now we're trusting weapons to make decisions, killing people with AI. So I think the more you connect, the more objects you connect to the internet, you need to, number one, policy, and I think that came up earlier in your talk, and mostly responsibility attribution. You can't take a software to court for killing people, can you? And so I think that's the first challenge. And there are lots of examples you can find in the news about how people are prioritizing security over availability, which leads to safety issues. So when you talk about the attack which happened in 2012, imagine an attack on the gas and oil infrastructure. If somebody manages to gain access to a pressure valve, for example, that would cause an explosion. That explosion could literally destroy the environment for many, many years to come. It could, the financial cost is massive, the interruption to the global supply chain in the energy sector, and so on. So in my opinion, the more devices you connect, you need to be specific, you need to think about the end user, what these devices are, the role they are playing in our lives.
Mm-hmm.
That's my view.
Right. Okay, thank you much, Mohammed. So AI, definitely, the upcoming generation is AI is going to be a big part of the next generation systems. In terms of security, how is that going to impact our systems? There'll be a good side of it and bad side of it, but which one will win? Will we have more advantages coming from the use of AI, or will security issues kind of compromise those advantages? if I can just have your thoughts, maybe I would say maybe in 1 minute, 2 minutes per panelist, please, because you have quite a few things to cover.
Dr. Mohammed just mentioned that technology changes is a challenge, which I agree with 100%. But as I mentioned, the human factor is a big challenge when it comes to cybersecurity, be it in privacy, be it in being vulnerable to attacks, being unintentionally leaking data. So AI by itself, does it harm the company to use? No. AI is a tool that will speed up your research or getting references or finding an information that you have not remembered for a while. But the user of the AI could jeopardize the company by leaking data. Like I have seen some scenarios where people were trying to thank their supervisor or their team for a work or a project completed, and they put the details of the project, the cost saving, how much they spent, all in the AI, and try to paraphrase that. Well, AI itself did not create that vulnerability, but the person who used the AI is the vulnerability source. Mm-hmm. So AI in general, I believe it's a great tool. And some of the companies now started getting their Llama in-house to train the AI engine on their documents, which is going to be safe.
Mm. Yeah, thank you much. Maybe Professor Mohammed
Absolutely, yeah. So like we had a saying that software is eating the world, you know, many years before. Now we say that AI is eating the world and software, everything. So there are two types of course, adversarial kind of AI, which we use for generating the deep fakes, for example, or misinformation, disinformation kind of campaigns, you know. So that is, of course, not a security threat. I would say it's a national security threat for any country, which we have seen in the elections or whatever, you know. And in COVID time also, we have seen a lot of misinformation, disinformation, which impacts our society. There is no doubt that they have serious, you know, implications on our society, especially on our kids, for example, they are seeing. And there are some kind of, pseudoscience kind of channels, you know, which are on the YouTube. You can find, you know, there are millions of views. They are creating the fake news and fake kind of science and, you know, having very devastating impact on our kids, you know, and education for their learning. So this is one of the aspects. And the second aspect is, of course, it's a good also for building the systems, for automation. There is no doubt it's a very fancy thing. Of course, we have to use it. But having these kind of challenges, of course, they will mushroom because you do not know that the nefarious actors, they would be using it for their malicious purposes. For example, launching automated distributed denial of service attacks or automated, you know, like campaigns for the phishing, spear phishing attacks and something like that. So of course, adversarial purpose is very dangerous. We need to have some kind of responsible use of AI. We need some kind of ethical use of AI, which is important. There comes the policy forward. So we need some kind of public policy to build about this thing because there are so many tools, you know, which are available publicly to make the deepfakes. Yeah. And why the platforms are not, you know, stopped to make these kind of things because they have serious ramifications on our society, and they are doing this thing. So I think it's a cat and mouse kind of game again, you know, so you have to build the strong, resilient systems which check the fact-checking, for example, for the news, okay, for identifying the deep fakes, if there is any kind of deep fakes being generated by this person. And unfortunately, you know, these systems have become so sophisticated, so there is very, very, difficult for even building the technology signal processing level. You cannot identify that it's a deep fake or original, you know, audio or video or something like that. Yeah. So it's a very big challenge, of course, for our society. It's not easy to address. Yeah,
yeah, thank you, Professor Mohammed. So, Mohammed Hamouda, what's your thought on this?
Well, very quick. I'll answer by giving you an example. So at the moment, I'm working on a project. I call it an active defense strategy, building or developing an active defense strategy where I'm building an AI hacker. So I'm just building an agent which will perform an advanced persistent threat for me. And these types of attacks, they're known to be expensive, they're known to be, they require high skills, they take around 6 months minimum to complete. So imagine you're doing all of that with AI as part of your defense strategy or even type of pen testing exercise. But I think another challenge is, so AI to me is software, and all softwares, they need to be secured. And we know there are many types of attacks against AI. But the biggest challenge that remains to me is explainable AI when you're making decisions, because that could be, any decision could be a result of an attack. And that attack could be small bias in the AI model. And of course, I can't end my response by not mentioning privacy, which you mentioned earlier. It's all of these AI models, they need data to be trained on. And that data, if not used correctly, stored correctly, and managed correctly, could lead to huge privacy issues.
That's interesting. Thank you very much for sharing your thoughts on this important topic. I think I'd like to take maybe one more comment from the audience, if we have any burning ones on this topic. The role of AI in securing our future systems. Okay. I think we have one here. I think we have two. We'll only take one for this time, and then if we have time, we'll take more at the end, inshallah. Yes?
Okay, thank you, Professor. I want to comment about what Professor M. Hamouda said about the safety. We should be concerned about the safety instead of the kind of cybersecurity attack. And we have seen like what happened recently with the Pages attack in Lebanon. And based on the previous presentation that Professor Mahmoud gave, he talks about autonomous control of these vehicles. So we can see that even though the next year we are going into now, it means someone autonomously can attack, can decide to lock your vehicle or direct your vehicle towards the location he wants you to be, or he kind of carry out a kind of attack whereby he will just decide to kill you or something. So where do we move from here? Like this technology, yes, it's it generates a lot of high-dimensional data, and it has become more and more difficult for us to kind of design a system that can cater for or control these kind of attacks. Then what is the way forward, for example? Like, what is the solution? What should we do?
Anyone would like to take this one?
Just quickly, from real-world example. So a few years ago, two American warships, they collided in the China Sea. And, people are wondering how on earth such, ships with state-of-the-art technology could simply collide in the ocean. It's not like a strait or a gulf, it's a big ocean, it's a sea. And the short answer to that is they prioritized security over availability. So they could see each other heading towards, they could see the ships heading towards each other, and they will be colliding. But they couldn't do anything about it because of the strict security mechanisms. So they prioritized security over availability and safety. And I think that triangle we had of the confidentiality, integrity, availability should be expanded to include safety these days, because safety and or availability must be prioritized over everything else, in my opinion.
I hope this answers the question. So yeah, moving on. So how can or probably what advice would you give to organizations looking to prove or future-proof their systems against any future security and privacy challenges? So maybe from business perspective, what do you think, Hussein?
Well, there are many ways to starting with a security program. You have to start with a security program. There are frameworks. There are risk frameworks. You have to adopt one of these and then start implementing the security controls. Like the most famous control is CIS, which is now version 8. They have about 18 security controls you have to start with and then implement each one of them, make sure that you implement them right. So it's not that difficult to start properly by adopting the right program. I see people who take these controls lightly, which causes, like for example, the first one is inventory of hardware. The second one is inventory of software. They think, oh, it's not really needed. So we know our network. We know the workstations. And then when an incident happened, they find out like there was a rogue device added to the network, which was the cause of the attack. Why? Because he left the first security control missed or was undervalued. So the proper way to implement a cybersecurity control is to adopt one program, adopt a framework, and adopt a risk framework.
Great.
Yeah, absolutely. So there are two aspects, which I would like to share here. The first aspect is from the business perspective, when we say that, so there are multi-pronged approach, here. First is the human, which we already discussed. So we need to build their capacity, train them, aware them. So this is the number one thing. Number second comes the technology, so state-of-the-art technology which you are using for the protection, for endpoints, for networks, for firewalls, whatever, you are using for OT, IT networks and something. And the third is the, regulations which we have. For example, we have very strict regulations from NCA for essential cybersecurity controls. For example, you have, CIS control, or, like compliance with the, NIST framework or Aramco framework, we have in-house framework for Aramco if you are working as a subcontractor. So I think these three layers have to be inculcated into the culture of the organization. So that is the most important thing, to have the resilience, because it's not about the security, so it's about the resilience, So we have gone more beyond that thing, The security, of course, we have a state-of-the-art system, but if it compromises, then would it be resilient enough to protect for the safety, before the safety, So that is another aspect. And if you see from another perspective, when we were talking about the artificial intelligence, so of course artificial intelligence needs to be the integral part of the organizations to use for the detection, okay, and to build the capacity also for the people, inside the organization. And the artificial intelligence, like we were talking about earlier, is we are using is just, we say it, artificial narrow intelligence, We are talking now we are talking about artificial general intelligence and artificial super intelligence. When this kind of intelligence will be inculcated into our ecosystem, so it is going to be more devastating for creating, more vulnerabilities, And of course, it would be creating opportunities also, like Professor Muhammad was saying, to build automated hacker, So it will exponentially grow your potential and capacity, to build this kind of offensive ethical hacking systems, to check the security of your systems, whatever, or networks or devices. And then you can have some kind of like labeling, for example, that yes, I feel satisfied and I have a trust in these systems.
Yeah. Okay, thank you much. Muhammad Hamouda, would you like to add something?
Just a dim view about this topic or this question. Not everyone can afford cybersecurity. So we need to worry about these small companies, these small businesses who cannot afford cybersecurity. So they need support maybe from the government, from academia, from maybe other professional bodies. Things like what we're doing now, exchanging knowledge, connecting with academia, connecting with other industry peers, they help in terms of enhancing the security posture. And you've talked a lot about the human factor in security, and I agree with that. And this is exactly the kind of activities that would not necessarily cost you a lot, but they can help significantly enhance your security posture as a small organization. But I think zero trust is where every company needs to start with. It's just the basic principles. It's about the philosophy about how you approach security. So using your legacy systems, you can achieve better security posture.
Right. Okay. Yeah, that's interesting. Thank you much. I think so far we've agreed on almost all the topics. I think I'm getting into a more controversial one. So the the next G system will be collecting a lot of data, personal data, analyzing it. And unfortunately, if we want to be part of that, then we have to let it go, basically. Okay. Now, my question is, what are the ethical implications of this? Of collecting and analyzing data, for personal data. It doesn't have to be personal, as Professor Muhammad was mentioning earlier. If I'm driving a Tesla car, maybe in the future, then I have to agree that that car will use mics, maybe everything, collecting a lot of data, probably more than I would be happily to give up. What implication can that have on our future societies?
Yeah, I think the privacy is a very major concern when you connect the systems, especially those systems which are bound to the human, like you are wearing sensors on your body, for example. You have sensors in your home, so they are collecting gigantic amount of data about yourself. It's analogous to the same thing like the social media platforms, collect our data. The Facebook can predict more than about you than any other person, even your family, because they have hundreds of thousands of, model points about the personality of a person, what you see, what you, for example, have, plan or whatever, when you speak also, so they collect a lot of data, AdSense, for example, in the Google. So similarly, this concept is coming to the connected systems also. So they are collecting the data, they are predicting about ourselves, what we are, and we have seen the incident also, what happened, a few months back for the supply chain attack. So I think these kind of things, when they will collect our data and use them for monetization, for generating some kind of business revenues for them, of course, that's devastating. So here comes the policy, legislation, law. So here should be, this kind of organizations should be taken under the law, and this should be coming from either from the United Nations, for example, we have United Nations, Cybercrime Convention, for example. If you collect a data of a person, without telling him or without his consent, so of course it's a crime, right? We have in Saudi Arabia, Saudi anti-crime cyber law, which is of course very old, 2 pages law, so we need to extend it and make it more concrete and more visible, and more detailed. So law will protect us, legislation will protect us, cross-border crimes, which are coming. Of course, we need to have some kind of collaboration and exchange between the law enforcement agencies to take the culprit to the court of law if they do like this. And especially the platforms like this kind of big platforms they have the social responsibility, So I think there should be some kind of policy and legalization from the governments, like we say, data sovereignty, So same thing applies to the data privacy also.
Okay, thank you very much, Professor Mohammed. Hussein, what do you think?
This reminds me of a story back in maybe 2011 or 2010. Maybe you have heard about it. One of the supermarkets, Target in the US, sent a congratulations e-card to an account, to one of the, and the guy was, he went nuts, like, a baby born? It's like, how did you know that my wife is pregnant? And it was a case where they went to court about it. Eventually, they found out that the buying trend for his wife, it went from buying the vitamins and the stuff that a pregnant woman would buy. So
right.
He didn't know she was pregnant, but Target knew before him. This was great, crazy.
It was 10 years before,
Yes.
And we're talking about the AI system now.
So
yeah, that's a bit scary.
It's a little bit scary. So when you come to privacy and how you are, and I think we don't have an agreement. Like currently, when we use the social media, we see ads. Some of them use tools or plugins to block the ads, and mostly, I think, majority would not. So would you prefer to see an ad is relevant to you, or see an ad that is, you didn't know why you're watching it?
Yeah.
If you give your information to the social media, to the collectors, they will give you relative ads. If you don't, you will see ads that are irrelevant.
Yeah.
So which one would you prefer?
Yeah.
To some extent, we have to surrender our privacy, to use those systems.
Yeah. I mean, you get it back as a service, basically. So that's the compromise you have to make. You get back as much as you give, basically. This is how it's becoming. So, Mohammed Hamouda, do you have any thought on this?
Yeah, I think from an end user perspective, it's interesting you mentioned social media, because we are voluntarily giving our privacy and our data away. And the lack of regulation, I think, maybe the regulation exists, but it's not enforced. If you try to connect a Wi-Fi network here in Saudi Arabia, it will ask you for enough information that they can produce a passport for you. They ask you for your date of birth, for your email, for your name, for address. I mean, why on earth do you need all of that information just to let me access an open Wi-Fi? So the obsession with collecting information, I think, needs to be controlled, or the only way to control it is by legislation and by imposing big fines. Big companies like Cambridge Analytica, they built, all of their data was collected in an illegal way, so the entire company was shut down because of that. And also the agreement, the use of data agreement between the user, are they using it in the way that you expect them to use it? And you're absolutely right. Now, social media or your mobile phone in general, it's your digital twin. Sometimes you don't need to mention something. You're thinking about it, and it happened many times to me, and then you start seeing adverts, and you're just thinking. You didn't say a word, you didn't search, you didn't do anything, but they can, it feels like magic, sorcery. So, so I think we need to invest from a technology perspective. We need, or companies or organizations, they need, like as a selling point for their products, they need to invest in privacy mechanisms like differential privacy. They need to provide guarantees to the end users that we're using your data in the way that you expect us to use it. And we are building those AI systems, because at the end of the day, anyone who resists embracing AI is, you know, I have my own opinions about such an individual. We should embrace AI. We need to make the best use of it, but at the same time, we need to have the technologies that allows us to use AI and build these systems, products, services, in a way that preserves the rights of the end user. And these exist. You can use, there's very mature differential privacy mechanisms. There are homomorphic encryption. There are federated learning, and much, much more that you can build these AI models without compromising the user privacy.
Yeah. Okay. Yeah. Thank you very much, Professor Mohammed, and everyone on the panel. Very interesting discussions, and I do have quite a few points to cover, but we don't want to stand between the audience and the lunch. So we would rather try to finish maybe in the next 3-4 minutes. So let's open the floor to the questions. If we have any comments or questions, please just raise your hand. I think we have one at the back.
Thank you so much for the session. I wanted to ask, how can we foster responsible AI use in organizations? How can we make sure that firms, people who work in companies are able to use this? Because this AI will come, it's inevitable, but how can we use it responsibly so that we protect our data, we protect ourselves, and yes, thank you.
Yeah, probably I would say Hussein would take that.
You know, when I first started leading the cybersecurity team, before that, I was an employee in another department or another division. And I was always complaining about not having full access to the internet. And why? The cybersecurity team would tell me, because of security. We cannot give you access to this website or that website. YouTube is blocked, Facebook is blocked, Twitter is blocked, everything is blocked. And when you search for something, I work at ITHRA, which is a cultural center. So we go to websites that have information about culture, a blog about an author who has a blog, and it is blocked. So I started complaining, and maybe this is why they moved me from communication to cybersecurity. And then I started getting into the people's mind, the cybersecurity team, which Dr. Mohammed mentioned, that safety is more important. He actually was pointing to using the systems. The system locked the ship captain from changing the direction. Similarly, our IT team or cybersecurity team were focused on cybersecurity, which made the internet not usable. I would prefer to use my mobile phone to search rather than using the workstation. Then we started changing the mindset. You need to enable the business to work in a safe and secure environment. So the cybersecurity, if you want a very cybersecure system, just unplug it. Mm-hmm. This is the way forward. But if you want to use the system, you want to use the technology, is to put layers of protection. If the first layer is breached, there is a second layer. and there is a third layer and a fourth layer. Responsibility comes with awareness. The user must be aware of the threats that come with using AI, for example. The threats coming from leaking sensitive information. We did not talk about data classification, but this is very crucial. The user has to understand what is the difference between company general use and private data and confidential data. Some of the people, they thought the bank account is confidential. Well, that's your private. The confidential data that comes to the company budget, to contracts, to information that could lead to changing the price of the stock in the market.
Yeah. Okay.
So it's so many layers or angles to look at it.
Yeah. Okay. Thank you very much, Hussein. I think we have time for maybe one more question. Probably, I thought to be sure. I think we have one here, and I promise we will stop here. So the message that I'm getting from you, Hussein, is if you want to be absolutely safe, you've got to be disconnected. Otherwise, you're compromising your.
Okay. Thank you so much for your presentation, Doctor. Very interesting for me, and very nice knowledge today. Maybe there are some standards specifically to the next generation technologies, how I can implement a cybersecurity system, for example, in a system, in a robotic system, for example. Thank you.
So yeah, it's a good question, because when we are going to develop the security system, so security should be by design, into the system. So this is a very important question, So once you build a system, security by design, and now, because coming back to the responsible use of AI, responsible use of AI is not, as a consumer, my responsibility. I should be using fair, transparent AI system. This is my point. But developers who are developing the technology, so they should be having responsible principles to inculcate into their system to be built. So this is another point. So security by design and security having a responsible use of this kind of technologies like AI, whatever you are using into the system. So this is very important. And there is another thing which is usually not discussed, but it is in, you can say, academic research, which actually we are promoting. Security by mind, It's more beyond than design. The people mindset, is very important, because the people who are designing or developing the system, so what is their mindset in the security? So that is also very important to be gauged. So how they perceive the security, from psychological point of view, and then develop. I can give you an example here. So some people are very much security centric, in their normal life. And maybe their sixth senses are very strong for the security. Have you seen some people who can predict sometimes, but it's very like sci-fi, it looks like. But frankly speaking, this is a mindset, security by mindset. That once you design the system, you have to have those kind of people who have very strong, mindset, knowledge, from their mind, to inculcate into the system. And then they design the system. And then they have different type of principles for the responsible use of AI, and transparent AI to inculcate into the system. Because now without AI, of course, we are not building any system these days.
Yeah.
Okay. Thank you so much.
Okay. I think this takes us to the end of this panel. I'd like to thank our speakers, panelists, for the insightful thoughts. So please, if you join me in thanking our colleagues here. Thank you very much. I believe it's lunch break now, and I believe lunch is just outside. So please enjoy your lunch and enjoy the rest of the summit. Assalamu alaikum.
Okay, assalamu alaikum. Good afternoon, everyone. Thanks for coming back, and I hope you have enjoyed your lunch. I'm ready for the next great talk from a great speaker. So it's my pleasure to introduce Professor Peter Bobowski. He is a professor at Aalborg University and a visiting excellence chair at the University of Bremen. He is an IEEE fellow. He received a number of prestigious rewards and prizes, such as the Danish Elite Research Award and Danish Telecommunication Prize in 2016 and 2020, respectively. He is currently an editor-in-chief of IEEE journal on selected areas in communications and the chair of the IEEE Communication Theory Technical Committee. He has held several leadership roles within the IEEE Communication Society. Without further ado, I will give the mic to Professor Bobowski so he can start his presentation. Thank you.
Thank you. Thank you very much, Anis, for the kind presentation, and thank you for the invitation. I will start slowly because I think people are still coming back from lunch. But let's get started with the talk. So I'm going to talk about wireless systems at the intersection of physical and digital time, and this has a little bit to do with the digital twin that was mentioned by Keysight, but it's a more of a more theoretical observation on the real-time intelligent and connected systems. So this is the outline of my talk. First, I'm going inevitably to speak about 6G or the next G, some personal view on what will be important for the 6G. Then I'm going to talk about how latency is modeled. You know, since 5G, latency has become one of the important topics in our community. So I'm going to talk about some aspects of modeling the latency, and especially the questions like if 5G was 1 millisecond, should 6G be 1 microsecond? And the answer is no, and I'll try to explain why. Then I also will talk about other measures of timing, which make the latency more complicated, and how overall timing is assessed within certain systems. And finally, I'm going to talk about fusion of physical and digital time, and how sensing and communication information could lead to effects that are maybe not observable in other non-real-time digital systems. So about 6G, so we start from this triangle that everybody was mentioning in 5G. So 5G was intended to make great communication technology. And I think 5G made a great communication technology. The point is that it's maybe not used in the way in which was envisioned, but this is coming. And we had a great panel yesterday where this was mentioned, whether it's a success or failure. There were some nice views about it. But overall, from a technical point of view, it's a great communication technology. But the thing is that there are many emerging applications like digital twin or extended reality or metaverse that are going towards fusion of the physical and the digital worlds. So when you fuse physical and digital world, the two things that you are fusing are also physical and digital space and time, right? So this will have certain consequences, and I'm going to talk about that later on. So in 6G, in addition to the communication, we are adding sensing and localization, and all of this is going to be connected with learning and inference with artificial intelligence. So this is the exact role that AI was going to play is debatable, whether in protocols, whether in physical layer, in higher layers, but what we are expecting to have is devices and network whose intelligence just grows over time. And the question is, how would you make communication protocols for those? There have been many use cases discussed about 5G, but I want to point out here a real use case that we came up with when we talked to the people doing biomedical research, especially people in rehabilitation engineering. I didn't know much about this area, but of course there are people that have certain disability, they need certain prosthesis and so on. And this area traditionally has been developed starting from very mechanical long ago. Then there was analog electronics, Then there are digital prostheses. And then we argued in this article here that the next stage is a connected prosthesis. So that the point is that, for example, a very complex robotic movement is how we are manipulating our hands. If we want to get a glass, or if we want to turn on a remote, or something similar. So all this has different modes of operation, and it uses our sensory perception and our nervous system to do the right thing. But when there is a prosthesis, this prosthesis doesn't understand the context. And the point is that there is a need for intelligence and connection that is going to explain the context to the prosthesis so that it can operate. And this is an example of something that needs to operate in real time, right? There are multiple use cases of this. One that's very interesting is remote monitoring and intervention. So when it's like with the autonomous cars in the talk that we saw before, we would like to have autonomous cars and robots, but we also would like to be reliably connected to them for intervention if it's needed, right? So if you have older people that cannot support themselves and they have exoskeletons, you want to be in a situation where remotely you can take over the control of the exoskeleton and help them. And this is kind of one use case for a very reliable real-time communication. So I mean, maybe it's not as major use case as remote surgery or autonomous cars, but I just wanted to point out area that has a real potential. And as I said, we discussed this with people that actually do this in biomedical engineering. So 6G is definitely expanding the connectivity horizon. First, in a conceptual way, as I said, that the question that we can ask is how to design communication protocols for systems that have continuously increasing intelligence. So now we are in the machine learning craze where there's better and better models coming and so on, and that's fine. But at some point, these models will be put into devices, will be put into the network. The question is, how do we interact with them? And what kind of communication this will require? Another thing, how it's expanding the horizon, is the non-terrestrial network, because since 2018, they are officially part of 3GPP. And you know, the satellite area, which was very well described by Slim yesterday in his talk, it has been evolving independently from a mobile wireless communication. Basically, in the beginning of 90s, there was this Iridium project, and we talked about satellite phones, and then suddenly nobody talked about that because it was 2G, 3G, 5G, and now we are back to satellite. I think it's one of the landmarks about 6G devices, because the ordinary user may not understand what is a FR3 spectrum or whether the physical layer uses deep networks, but will understand if the device can connect directly to satellite or not. And I think this will be maybe the new feature of the 6G devices. So also the impact of intelligence in the nodes has been a bit captured through this concept of semantic and task-oriented communication. I will not speak much about it because the next speaker is going to explain more about it. What I wanted to say is that we can make this interesting parallel towards linguistics. And then you can see that whatever we have been doing in communication systems spans just the 3 layers of linguistics up to the syntax. But then conveying meaning and actually using real-time information to make decisions, it's something that has been done on top of it. So there is a vacuum, obviously. And research doesn't like vacuum, actually it likes vacuum, because then you define research topics. And this can be also mapped to the way the Shannon, actually not Shannon, it was Weaver that described this in the introduction to the Shannon's paper in the republishing into 61. So in short, semantic communication, goal-oriented communication is possible, is interesting now because of the growing intelligence in the nodes. So let's look at the latency. So the latency, we can classify it in different levels, different scales. So people that work with Open Run, like Slavomir, would recognize this, because there is something that is called real-time, near real-time, and non-real-time, and they have different latency requirements, different timing requirements. It's not always latency, sometimes it's a closed loop and so on. So in real-time is below 10 milliseconds, near real-time in 10 to 100 milliseconds, and above that it's a non-real-time. So on the other hand, in 5G, we talked a lot about this latency and reliability. So in short, explain in short what is the latency and reliability and what the trade-off between them is. Let's say that we have a system that wants to deliver packets, and we would like this system to deliver packet until a certain time. And this is, of course, a statistical event. You cannot deterministically guarantee that the packet will arrive. But what you can say is that you can use methods to make it sure that the probability that the packet comes increases over time, right? So you can do improve your power, retransmit the packet, and so on. And this is a very simple diagram that captures, that says, okay, this is the probability that the packet will arrive before time t, and this is the time t. That's the latency. And then what we would like to do is that the packet arrives by a certain deadline. We want probability to be larger than some value. If it's not larger, like in the blue curve, we have to go to the red curve. But the red curve assumes that you invest in the system. You invest energy, you invest frequency, you invest antennas, and so on. So moving from the blue to the red operating curve means that you improve the latency and reliability of your system at certain cost. And so we can use, for example, frequency diversity as a simple example. Basically, if you have infinite bandwidth, then achieving low latency is a piece of cake, right? Because you just use infinite bandwidth to send at a very high reliability. So the problem, though, with this requirement from 5G is that this low latency, high reliability requirement of 1 millisecond is in principle problematic, because if you look into the overall chain of the latency budget, you have used timing for computation, then for compression, propagation through the core network. And here, there is physics. You cannot improve this, because if it's 300 kilometers, that's the time that it's going to take to propagate, right? So you see here that 5G is put in a very unfair situation. It's like a low-paid worker that does the whole work for the company, right? This sounds familiar, for example, in the US. Anyway, and so the point is that with 5G we have a very stringent requirements, and the question that I want to answer here is: do we need those stringent requirements? And if you look into the 3GPP, actually the stringent requirements is over a communication channel. But if you look into end-to-end latency, there are other components. I don't know whether you have experimented with it, but if you take compression takes a lot of time. So it's not that everything is done quickly and then you just need 1 millisecond. So compression, for example, of video, it can take 15, 20 milliseconds, depends on the processor. So here is a simplified analysis of what is the overall latency budget. You have, for example, computation, compression, and communication. So if you put the end-to-end latency, then what you can say is that, okay, I would like to meet the deadline with all these three operations. Or I can separate the operations, or I can couple the operations. I can say, let's do the communication and compression in a way in which they're coordinated, and then I just put the latency on the communication part. So for example, if the overall latency should be 5 milliseconds, I can say I put 4 milliseconds here or 1 here. Here I can say I put 1, 2, and 2, right? So this is how we can separate them. Or here I can put, for example, 4 and 1. The point is that, and this is one of the things that the critics of Open RAN say. They say, okay, Open RAN operates up here, where you do not control the components, all components, and then you want to achieve end-to-end latency. The closed vendor operates basically at this point, where they optimize all operations, and they say that they can offer better latency. This theoretically can offer better latency, but I think the one up is more adaptive to unpredictable scenarios. This is the main difference. So mathematically, the expected latency here, even if these times are dependent, this is a very nice property of the expectation that everything is linear. But if you look into the latency and reliability, then things are not that simple. Because here, you actually want to put constraints on each of these. And you cannot sum up these probabilities. You have to do something else. And the question is, what should be the constraint that you put on different operations? Because Compression and computation, they're also stochastic because there is a stochastic element in the computation of how much time they take, right? So for example, your packet can fail to meet the deadline either because of one of them or because of the second or because of the sum of both, right? So here is an example of a study we did, again with our friends from rehabilitation engineering, about a human operator that works with a hand in remote, robotic hand in a remote environment. So we looked into the overall latency budget. So how much every operation takes. Then the point is how you can optimize this. You can optimize by, for example, putting a stronger processor, making faster compression. Then if you make faster compression, data will be better compressed, and you have more time to send the data. So your rate doesn't need to be very high, so latency and reliability can be satisfied. But then you invest it in a processor, right? So this is the overall diagram. The interesting thing is that if you can have dependency between these different times. For example, if you take an open RAN system, or if you take an open system, where you use a single processor. This single processor is used for compression, but also for communication. That means that the cycles of that processor will be taken by both operations, so they become dependent, their latencies. So characterizing that, I have not seen any study that characterizes that. We tried out something here. But I think these are interesting things when we start to claim that we need a low latency. Now you start to see that this 1 microsecond for the wireless part starts not to make too much sense because the computation works with milliseconds, right? So the question is, you know, how do we get how to optimize the system? And here is just a sample of results. What we are saying here is that we are looking for the optimal point, giving the reliability of 0.95, where how much processing power should be used in order to achieve this latency. So you see that if you go from 1 to 5 gigahertz, you can actually spend less time on the compression, and then meeting the deadline becomes easier. Because then the rate for the rate that you have to use in bits per second for the communication is lower. So my main takeaway of this part should be this here. So this is the time it takes to process the data, compress or compute the data. The time it takes is basically the data size divided by frequency with some random factor. And this random factor is gamma distributed if you look into the computing literature. So the processing time is a random time. And you know, if you take these values, it goes into milliseconds and so on. Again, this is speaking against the microsecond requirements of 6G. Okay? Then power consumption usually scales with the third degree. Actually, this is not correct. There's experimental results that say that it scales with second plus something degree. But let's take this third degree, which is very often used in the literature. Energy consumption scales as a power consumption with the time that it takes to process. If you remove the random factor, it's f to the square d. So what does this tell us? That latency requires fast information processing, and fast information processing requires high energy cost. So the question is, if we require low latency, 1 millisecond or even less, what is the cost? The cost is the energy. It's like having somebody being constantly alert. I mean, if you are constantly alert in a, I don't know, in a playing chess or whatever, then after that you're tired, right? This is exactly that. So that means that to have efficient systems, we have to adjust the latency requirement to the current needs, maybe to the task that the system has, or to the context and so on. Okay, so this is a paper that we published in the Transaction on Haptics, where we took experiments with people controlling things with a joystick and trying to see how much latency was having an impact on it. The first interesting things that we noticed is we emulated the packet error rate and the latency on the link, and the person that was controlling was basically, now when I tell it, it's obvious, but it was not that time. The person is learning the latency. So if you change the latency and packet, the person is adapting to it and then can still control the trajectory. So how did we do the experiment in the end? We had to make an unpredictable trajectory, and then we correlate the control trajectory with the unpredictable to see how well it is controlled. That's how we assess the impact of the latency and reliability. And the latency in the closed loop was more than 150 milliseconds. Another surprising result was that we used the control with visual feedback or with tactile feedback. And the impact in the two different cases of the latency was quite different, which is telling you that you don't have universal latency requirement. You don't have to have 1 millisecond. It really depends on the negotiated parameter and the context, right? And so the performance was affected by the average latency, but not the jitter. And as I said, the most important was that the different mode of operation was requiring different latency. What does this tell us? Is that if we have a different level of intelligence in the nodes, the latency requirements will change. Or a different type of processing or a different investment in the processing, the latency requirements will change. Okay. So, but latency is only one measure, basically from when the packet is put for transmission until it's received. Or a closed loop is from when it is put until it's, the feedback is coming back. But which are the other measures? So, for example, one measure that has been popular in the last 15 years is the age of information. So age of information is, the key assumption is that the fresher the information is, the more relevant for the system. And then it has been shown in certain control systems that is more relevant than the latency. Because when you sample the state and how much time it goes since you have sampled the state. The difference of age of information and latency is that if you have a fresher data to send, you might drop the previous data and just go to the send the newest one, right? Then we had this project with Bosch from Germany, and my PhD student who was working there, he wanted to measure the age of information. And then he realized that it's not easy to measure because you have to perfectly synchronize the two ends. And then what he realized was, okay, instead of measuring the latency, I can measure, see, this is a controlled vehicle. The vehicle senses information, sends it, and then it gets a command back. So what we are measuring is the freshness of this loop. So when should I sample in order for my question to get the freshest possible command? And we call this age of loop, and this is very easy to measure. And it turned out that if you use this age of loop and use some reinforcement learning, then the bandwidth that you should use is very low to keep the system stable. On the other hand, if you want to have the URLC style, high reliability and low latency, you are here with the bandwidth. So this is telling you that age of loop is a measure which kind of adapts to the task and uses less bandwidth, or you can equivalently say less energy. So another thing that complicates latency is the difference between push and pull communication. And we learned this by talking to computer scientists. So push-based communication is basically the Shannon's communication model. So in the Shannon communication model, there is a thing that Shannon never talks about, and that first of all, A, that sends data to B, is always ready to send, B is always ready to receive, and B is always interested in the data, right? That's the assumption. We do not question that. But if you talk to computer scientists, they say, okay, so what the system that you have there, it's called permanent subscription. So permanent subscription is like having this daemon in Linux, and then whatever comes, you say, I'm interested in this, take it. But there are many systems, like satellite systems, which gather data, or cloud-based queries. Somebody said yesterday that there will be more queries coming from the edge. I mean, I don't know whether it was Michael or some of the speakers yesterday, that a lot of the traffic will be driven by the queries. But these queries, actually, the latency is not measured as before. The query is measured with respect to the moment when the query arrives, because that's why you want to measure it. So we have defined something that is called query age of information. So if somehow you announce to me when you are going to ask for the data, I'm going to prepare so that the data is ready when you are ready. That means that in the meantime, I can sleep, I can encode the data, I can do computation. And this is very important for satellites, for example, that you can, when the satellite passes, and you know this is pretty deterministically when it will be, so the satellite can use this intermittent time for computation. And the computation can be slower with a lower frequency, then the energy consumption goes down. Right. This is an example if you optimize for query age of information versus age of information. For query age of information are the red dots here. So you optimize to have fresh data when they are asking about this data, while the average of information is optimizing on average. And last thing is there is one way in which information can propagate faster than light, right? So against the laws of physics, no, this is of course not true, but there is one case where this can happen. That's when you do prediction. So if you have a prediction, you know what will arrive before it arrives, right? So that's the point. So the question is now, with the growing intelligence, how should we redefine the communication, and how can we mitigate latency? For example, right now, the routers in the network, they do replications, and they take the data, replicate it, send it, and so on. But in the future, there will be nodes in the network that are very intelligent. And these nodes will have a good model for me as a sender and good model for Slim as a receiver. And basically, instead of replicating the data to a router, we connect to this common node that facilitates our communication at a low latency. So this is not a new idea, because in gaming, prediction has been used before. So if the packet is too late, then the gaming just creates an environment and hopes that it's the right environment. So you can measure this correctness based on how correct is the generative AI. For example, if you are watching soccer, then whether it creates a soccer field, whether it matches the colors and the positions and so on. So this is how you can measure it. So it's not with a square distance with an MSE, but it's, for example, with inception distance. So what I want to say here is that if it can be predicted, it does not need to be communicated. And this is the principle, right? So the question is now how much you can do the prediction. So without going into details into it, let me come to the last part, which is this physical versus digital time, causality, and simultaneity. And this is pretty much related to the topics done in this communication and sensing group, which was presented today. But it's a little bit of a different aspect, I would say. It's more related to the digital twin that Michael presented yesterday. So let's start with an example. We have a robot, and we have a base station. There is an event, thunder. And this event sends acoustic signals. And the robot is receiving the acoustic signal. On the other hand, there is a sensor next to it that receives the acoustic signal. But also this event here causes another event, which is E2. Something else. For example, there was a door opening, and this door made that somebody else enters the door or something moves and whatever. This is the second event. The second event is perceived by a radar sensing, integrated communication and sensing, for example, and by a user or a device that observes it, maybe visually, and processes the data. And then this user sends the event to the robot that perceived it. Okay. Now, look at the physical process. There is a E1 that is received as a data, digital data by the base station, but is received as a sensory data by the robot. And then you have the other event, which is received as a digital data by the robot, and as a sensory data by the base station. So it's multimodal, right? It's multimodal events, multimodal sensing, and so on. So if you show this to somebody, the question is, what happened before the other thing? What has caused what? Is it E1 causing E2 or E2 causing E1? They will not agree on this, right? Okay? And so this means that digital and physical time get intertwined. So right now, we can agree here, all of us, about the sequence of events in this room, because we all have similar perception. That's the human perception that developed throughout evolution by adjusting the windows and so on. We'll come back to that. But what in the future if our devices cannot agree on the course of the events? What will happen in 30 years if somebody comes to a court about the traffic accidents between autonomous cars, and then we want to see whether there was a horn first, there was a turning, or there was first turning, then a horn, and so on, right? Right now, this seems obvious with our time scale, but the machines will have a different time scale. That's very important to know. Our time scale is very limited. What we call now, as humans, is what happened 150 to 200 milliseconds ago. what machine might call now might be something over 5 milliseconds. So that means that the way the machine perceives reality is different from us, is different from another machine. So the question is, how do we reconcile this? Of course, we can reconcile by putting the timestamps to everything, right? But nature doesn't make timestamps. You know the events when you see them. The nature is not sending you clock. You are ordering them by reasoning and by considering the sequence of the events. Okay, then who talked about these things? Some very famous people, like the one that you see here. If you have read his book, which I'm sure many of you have read, one of the popular books, he talks about this simultaneity of the events. It's great examples. What he doesn't talk about is how much time it takes for the perceiver, for the observer, to process the data. He doesn't talk about that. So that means that in Einstein's world, the sequence of events is decided instantaneously, right? There's an event EA, this is the cone of causality, and speed of light, and then the events are received, right? Then another person that talked about similar things, inspired by Einstein, back in '78, is this one. How many of you know who is this? Okay, I can tell you that 90% of you are using his product every day. This is Leslie Lamport, the person who created latex. But he's also, actually he was hired by Microsoft later on, but I don't see that Microsoft is still approaching latex, so I don't know what happened there. But he wrote this groundbreaking paper about time clocks and the ordering of events in distributed systems. So he's telling how computers would agree what happened before. And this was '78, you know. Very few people knew what computer is. But these algorithms are used in distributed computing when, for example, you're doing online betting or you're doing online reservation of hotel and so on. So it just decides who was first, what happened, in which sequence the things happen. Okay, then I was, of course, inspired by these works. But then I think in our case, we have another element which is interesting in communication networks and sensing. That is the time used to process information. If you communicate at a low rate and compute at a low rate, the reality for you goes much slower. If a sensor has a certain sensory time for integration, then this is the way in which reality happens for this sensor. If you do a shorter time, the sensor will make mistakes. If you do a longer time, the sensor will detect less events. If you want the sensor to be precise and to have shorter time, you have to invest in processing power. Then the battery goes up, right? So obviously there is an interplay between energy, information processing, and time. So this is what I also mentioned before, that now is defined as a processing of the outcome of the sensory inputs. So basically, if you, the brain is doing this with using these temporal windows of integration. So for example, if I clap my hands now and look at them, there are three senses there. There is a visual, which is very slow, because it's a very complex. There is acoustic, which is very fast processing, but is slow propagating. And then there is a tactile, right, which is propagating through the nerves. So this is multimodal. The point is that if you have base stations in the future that have multiple sensors, we are facing pretty similar situation, right? That they have to timestamp somehow this. Because what is the objective of it? If you timestamp the events of the base station, and if you give it to some algorithm for learning, and if the timestamps are changed, then the learning gets totally messed up, right? So the point is that the brain has figured this out, and then makes these temporal windows of integration, and everything which comes within those windows is considered a moment. Then, so one thing just to mention here is that for the brain, we have this simultaneity horizon of 15 meters. So if things happen within 15 meters, then the times are calibrated to represent them simultaneously. But if a thunder hits 3 kilometers away, it's not simultaneous, because evolutionary it was not important. I mean, thunder is far away, and you don't need to perceive this as a real event, right? So you consider it as two separate events. So then there is this trend of calling the perceptive networks, mobile networks, where we use sensing and communication. And that's motivated me to write this work, which I'm very briefly explaining now. And I would very much like to see what I'm talking about here to be tried out with sensing systems, with digital twins, and so on. If you read this paper from biology, which explains how the brain works, there are multiple mechanisms by which brain adjusts to reality. But you see, now we're having AI, base station, multimodal sensor information, so we are kind of converging to that stage. So the question is how we are going to treat the temporal ordering of the events. So just quickly to go through this, I made some models for synchronous, asynchronous sensors, and then the key point, the key trade-off is how to choose this window of integration. If you choose it large, then the resolution of the reality is low. If you choose it small, then the probability that there will be violation of simultaneity and causality is high. Then how do you choose it for different scenarios? Then, of course, the answer is that you have to see what is the use case and you have to adjust your temporal window to it. Some of you might say this is not a good system design if you choose this parameter, but the counter answer is that this is exactly what is done in OFDM. They look in which environment operates, and this is the guard interval is selected based on that, right? So nothing new in that. So this is how it would work. There's a physical process, device A, device B. We look what is possible with the processing. Again, the assumption for humans is that we have certain processing speed. That's why we have similar, how to say, windows, but the devices will have different. So the question is how to choose these windows, especially if we have multimodal propagation. Then, for example, here I'm showing a very simple math, how to choose the window to avoid that there is always causality violation in certain scenarios. But then you cannot avoid it always, the causality. It will happen. And then the way you will correct about it is, of course, by intelligence. So if something does not work well for the temporal ordering, then the intelligence comes in, steps in, and actually corrects it. And this is what our brain is doing all the time. Come back to that later on. The thing is that if a device uses prediction and generative AI, then the time can be completely messed up. Then if somebody has a good predictor to inject data, or even fake data, then when we look into the log of this data, we cannot agree what happened. Because somebody else was injecting data at a very high speed. Imagine if we face aliens that are processing information 10 times faster than us. It's difficult to coordinate, right? Because everything you see is a subset of what they do, they see. Right? That's kind of the thing that we are facing with the machines in the coming years. So I don't have so much time just to say what is the implication of this. First implication is that on the latency requirements, I tried to explain before that we should not just go for very low latency, milliseconds or microseconds. We have to choose the right latency because that affects our power consumption and so on. So if we want to strike a good balance, then we have to look into the latency requirements that are derived from certain applications that have these temporal windows of integration and so on. Second, from a purely optimization point of view, this might put constraints on how we allocate the resources for different applications. So for example, if I have application with short window, application with long window, and then I have to accommodate sensing and information and communication, so I can define a scheduling problem, hopefully non-convex, so that you can publish the paper, and then you solve it. Second point is a temporal forensics. So the thing is that base stations are the points through which the physical world enters the digital world. And that's what our community is doing, right? The designing base stations and so on. How will you ensure that this is certified and trustworthy? So how you will ensure that the events in the physical world and the events in the digital world took place in a certain way? That's the responsibility of the base station, because the AI algorithms come on top of that. So if you see what the brain okay, let me just skip this. If you see what the brain is doing, is brain is taking these temporal events, but then correcting based on the predictions. And so the reality is, fortunately or unfortunately, by us, never perceived as it is. It's always with a bias of what our brain knows, and with certain even modification of the sensory information. Where we have seen this before, we have seen this with magicians, illusionists, right? So they always manage to trick your senses, because they make the prediction of your brain to be different than what is happening. Why is this important, in my opinion? Because if we can have access to these large digital systems with sensing, communication, and data about everybody, how will these illusions look in 20 years? You know, most of the people get their reality from the smartphones. Imagine if they get integrated and there is an integration of physical and digital time. How do we ensure that there is a true order of events? And that is, I think, something that is a role of us as communication engineers and engineers that make the systems, as we discussed yesterday with Slim. So, okay, so that brings me to a conclusion. I tried to convince you that timing is not as simple as just a latency. It depends on multiple components. And there is an intertwine between computation and communication. And this is pretty much what also yesterday Slavomir said. Then packet transmission is just an instance of general timing measures. And I think intertwining of physical and digital time depends on the information processing. So I think the analysis I have shown is very simple. It's yet to be evaluated experimentally and see what is the impact by learning algorithms and so on. But maybe it's a first primitive step in some direction where this integrated sensing and communication and AI is going to develop within the next G. Thanks.
Thanks for the great presentation, Professor Bobowski. So we have time for one question only. We need to move to the next speaker. Yes.
Thank you for the very interesting presentation. It's a question or comment. I'd like to hear your... I think a lot of the latency we have in the network is not really useful latency. It's not really, let's say, used for its purpose. For example, if you look at one of the songs for kids, it's downloaded 100, maybe trillion times or so, like Baby Shark or so. And I think the point is that there is an intentional, let's say, act by some of the data users to make sure that you don't have the data. So if you get my point correct, that a lot of data being intentionally loading the system.
Because that's the incentive in the system, right?
Yeah, right.
I mean, the opposite of this is what has been done with caching. Instead of asking the data from the source, you push the data close to the users and they take it from the edge or close by. But the thing you're mentioning is very interesting. There is an incentive to use more data.
So maybe we should work on this, find other ways, because otherwise we are not really serving people who are not connected. We are serving people who want more money in a way or another. So I mean, this one thing that if you want to reduce latency, maybe we need to think about somehow content management or so.
Yes. I mean, if you want to, would be at the higher layers, I would say. And again, here the examples I was showing was that if you have a system that has an objective to minimize the latency, that's what you have. But if you have a multiple competing, which have different incentives, some of them want to maximize data minimum latency, that's a more game theoretic problem, right? Which I've not really considered. Here I tried to just take which are contributors to the latency. Once your intention is to minimize the latency.
Please join me in thanking Professor Bobowski. Thank you. Thank you so much. Thank you. Yeah. We move now to the next speaker. He was one of the participants in yesterday's panel discussion. He was introduced already by Professor Daniel, but maybe for the people who joined us today, I will make it very quick. Professor Slomar Stanzak is a professor of network information theory at the Technical University of Berlin and the head of the Wireless Communications and Networks Department at the Fraunhofer HHI. He's a co-author of 2 books and more than 200 peer-reviewed journals and conferences, journal articles and conference papers in the field of information theory, wireless communication, signal processing, and machine learning. He was an associate auditor of the IEEE transaction on signal processing from 2012 to 2015, and chair of the ITUT focus group on machine learning for future networks, including 5G from 2017 to 2020. He's also a project coordinator of XG Incubator since November 2023. Without further ado, I will give the mic to him and he can take it from there. Thank you.
Okay, thank you very much for the nice introduction. It's nice to be here. Thank you for inviting me, for giving me this opportunity. I'm not going to talk so much about task-oriented or semantic communication, but I will start with energy efficiency. And this is good. This was a good question. First of all, this is, rebound effect, right? I think that the first important thing is that we have to differentiate between energy efficiency and energy consumption, right? So if you look, at the energy efficiency of different generation of mobile networks, 4G, 5G, and 6G, okay, 6G is not there, but this is what is predicted by Nokia. So the energy efficiency improves from generation to generation. But of course, energy efficiency is energy consumed per bit, but we consume more bits, and then, of course, the energy consumption in the end is higher. And this is the rebound effect. The more efficient we can use a resource, the more intensive we use this resource, right? Okay, so we have to be careful and different between energy consumption and energy efficiency. And one important thing is, if you want to hope to reduce the energy consumption, then you need to change, in fact, scaling laws in your networks. So by scaling law, I mean, for example, how throughput scales with the energy consumed per bit. So you have to, this is a fundamental change. It's not only just, to improve constant, but it's, you want to change how the network behaves, with respect to some basic parameters. And I forgot to mention that this energy efficiency gains from generation to generation are mainly due to improved hardware. So the hardware is more efficient but on the protocol side, there are not so, much gain. So first of all, our, approach in this project 6G RIC, 6G Research Innovation Cluster is, can be summarized, as consisting of these 3 components. Self-remissive MIMO. Basically, this is what Slavomir said yesterday. Today you have AP surrounded by users, AP as access points or base station. And then the idea is, you have users surrounded by access points. Okay, and then in fact, mathematically you can prove that if you want to change scaling law, you have to you need more dense networks, or you need a lot of collaboration, cooperation between users. Another thing is task-oriented communication, which means that you transmit less data over the wireless channel, and of course, energy-efficient hardware. So let me start with self-remissive MIMO, what it is. So it matches benefits of dense networks and cooperation of simple access points. I think that the main point is density and simple access points, sometimes called distributed MIMO. And it's a refined theory and operation regime based on massive MIMO. It's not coordinated multipoint. The problem with coordinated multipoint was that this approach imposed strict requirements on the fraud hole, because it requires exchange of instantaneous channel state information between different base stations. So that's why the system wasn't scalable. Here the emphasis is on scalability, so you have a collaboration, but you have to reduce the overhead due to the collaboration. Fairness and user-centric design. That's why you have user surrounded by access points. So you have some kind of uniform coverage. Okay, so, and key questions are, you know, if we resort now to this ORAN architecture with RU and DU, so key question is which network element should perform which task based on which information. And so today Slavomir said that what we want to have is simple access points, simple hardware, and more or less, if I understood this correctly, the whole intelligence is moved to the DU, right? And implemented in software. Okay, I mean, there's a big debate. This is taken from a paper of Ericsson. And then the scenario he mentioned is this here on this side. Yeah, so this is, you know, what you have locally is only, you know, some kind of beamforming, but, you know, channel estimation and all this stuff is done on the DU side. The problem is, of course, if you go to scenarios with many antenna elements, then there is a problem with delay. Of course, because just, you know, the channel estimation effort increases, and then takes much more time to get, you know, this information to the DU. So you have to cope with the outdated channel state information, and this is a big problem. Why? Okay, so let us look, you know, let us explore this a little bit in more detail. First of all, there is a theoretical framework called Team MMSC that allows you to cope with or to implement or to design distributed beamforming systems, right? It's a you know, multi-agent systems or where the agent, you know, minimize some global cost function or objective function, in this case, minimum square error, under uncertainty. They don't have perfect channel state information or global channel state information. So now you look, you know, for example, local CSI, you could say, okay, I have instantaneous channel state information, and then I use the instantaneous channel state information only locally at the access point to compute, you know, MMSC beamforming locally, ignoring, you know, the other access points, ignoring the interference. Or what you can do is you could move this instantaneous channel information to the CPU, central processing unit, and, you know, and do some kind of centralized beamforming, right? So you can see that here there is a simulation. This corresponds to this local beamforming, and the red one to the centralized one. So there is a gap. So say, you know, if you do things centrally, you can have some signal performance gains. But the first message is that it strongly depends also on your scenario. If you have strong line of sight, then the gains are negligible. So in this case, you can do everything locally. But if you have, you know, for example, dense network deployments, the probability of having, you know, line of sight is much higher. No? So that's why, you know, this is a quite, you know, practical scenario. Now, on this, on the right-hand side, what you can see is the same scenario with 2 access points, but now we have a problem with delay. So that we assume that this channel state information can be delivered to CPU, but with some delay. Okay, so the CPU doesn't have, you know, the current channel state information, but delayed one. And then what you can see that now the distributed beamforming, I ignore, you know, other access points, performs better than the centralized one. So that's why this is an issue, especially if you go to MIMO systems, if you have access points equipped with multiple antenna systems, this is a problem. And then if you use this, for example, Team MMSC framework to do things in a distributed manner, and for example, you use instantaneous channel state information locally, but for example, you exploit statistical dependencies between different access points centrally, then you can improve performance significantly. And this is explained here. Conventional short-term approaches, conventional I mean because I spent almost all my life using such approaches. How is it? You have, you know, channel state information H at time point 1, 2, and so on. And then you take the channel state information, and then you, for example, compute beamformer and transmit powers. Every time the channel state information changes, you solve another optimization problem. At one point, I realized, especially if you go to distributed scenarios, this is not feasible. This is not practical approach, right? So here the idea is that you have to decouple. So everything related to instantaneous channel state information, is done locally. But at the central processing unit, I mentioned this before, you exploit some kind of statistical dependencies, between different channels. So that's why you can see we have some kind of long-term optimization problem. We use statistical channel state information, compute P and F. P is, transmit power, but you can also assume that there is no power control. But if there is power control, you can compute P. And then you compute function F that relates global channel state information to your local precollars. Okay, and then if you do this, you can see, for example, in this simulation, that this red one is short-term optimization. And then this one is the distributed one. The gain, the loss is, you have a significant performance gains. But this is if you look at the sum rate. Now, if you go to the minimum rate, so it's about fairness. This is just, I am interested only in the sum capacity on sum rate. If you go to the minimum rate, it turns out that this approach is better than this one. This is simple, to explain because this has something to do with max-min optimization problems. That it's not good if you have max-min optimization problem to maximize in every time slot. It's better because then you have to maximize the worst user in the system, right? So that's why, the second message is I try to convey is that, it depends also on the metric you are interested in. Are you interested in sum rate, some kind of utility optimization, or are you interested in fairness? Okay, so there is also one misconception in the literature. You can even find books. They claim that small cells, which means they treat interference as noise, are better in certain regimes than the cell-free massive MIMO. If you think about this, you say, okay, how can it be, right? Because cooperation cannot harm. If you don't cooperate, for me, it's a special case of cooperation, right? So that's why, first of all, the curves, if you look, this distribution function, they have to look like this, that cell-free massive MIMO cooperation always outperforms small cell deployments. And this is, also related to, Slavomir was talking about this scheduler that is just coordinating different access points. It cannot be worse if you don't have this this global scheduler, right? If it's worse, something is wrong with the design of this global scheduler, right? Okay, so this is the first part. So as I said, cooperation is always beneficial, but the question is how much and what cost. It depends on the channel. If you have line of sight, then I would say do things locally. And it also depends on the metric. Are you interested in fairness or are you interested in utility maximization? So, and decentralized processing can reduce complexity overhead while delivering excellent performance. So you can do things, as I said, in a distributed manner, and globally you can only take into account this statistical dependencies, and that's why you can reduce, the requirements imposed on the front haul, on the front haul. Okay, so there is a catch in the whole thing. In order to solve this long-term optimization problem, in fact, you need, some kind of knowledge about the distributions. And this knowledge is not given. That's why what we are doing right now, we try to use, some kind of ML algorithm to solve this problem. And the second thing is, we are, of course, interested in demos. And there was a first demo last year at ICC in Denver. And so what we use, in fact, we use ORAN systems, but also open source based on OpenAI interface to, to demonstrate the benefits of a cell-free massive MIMO. Okay, so regarding, I was thinking whether, I should talk about this topic, but AI is everywhere. And then after some discussions here, I included this part. And also, I was attending the Brooklyn 6G Summit, and there were some guys, and then they were quite aggressive and said, neural networks are great to be deployed at the file layer. So in fact, you have, some kind of, autoencoder or neural networks deployed at the file layer, and then these neural networks, they solve all the problems for you. You don't need to do, you have to only train offline and maybe adapt a little bit. So the problem is that here there's a simulation demonstrating what, the main challenge is. Here, we were interested in the reconstruction of angular power spectrum, and but this is not so important. And then here you have simulation normalized mean error. You have for no distribution shift. It means that you draw data from some distribution, you train neural network, and then you check the performance of the neural network, right? But then you have distribution shift. And this is what happens in wireless systems at the file layer. The distribution, not only the channel changes, but also the distribution of the channel changes very fast. In mobile scenarios, every 10 milliseconds you have, you may have different distribution. So you can see that the performance of neural network breaks down. So in fact, what you have to do, you have to adapt, or you have to retrain. You have to do something. And in fact, neural networks, for me, they are not designed, to include and to do this, in some kind of systematic manner. First of all, you have little time at the file layer, and little also small amount of data, right? So on the other hand, there are other algorithms, data-driven machine learning, maybe not AI. I call this data-driven signal processing, or data-driven machine learning. They are quite robust. They are robust to changes in the distribution. Maybe you need some kind of fine-tuning, but even if you don't have data, they provide some kind of meaningful performance. So in fact, what we do is we use, this set theoretic methods, and then they can be applied, because this is a mathematical concept, they can be applied to different problems at the file layer: multicast beamforming, MIMO detection, hybrid beamforming, channel estimation, PRPA reduction, and so on, and there are papers on this. And let me explain this, using the signal detection in MIMO systems. Probably, people who work on MIMO are familiar with the problem. This is just maximum likelihood problem, right? And that's NP hard. There is no hope to solve this in a, an efficient manner. And in fact, this is a nice convex function. The problem is that you have to optimize the function of some discrete set, right? This is the constellation of your modulation, right? And then if this set is big, then you have a problem, right? You can solve this problem, of course, always, but you have to maybe go through all the points to find the optimum. So that's a large-scale system called for approximation techniques with very low complexity. Okay, and then there are some approaches to this. Of course, you could use, the single shot like mesh filter 046 LMMSC, far for optimal. Then there are these probabilistic methods like projection gradient, alternating direction method of multipliers, ADMM, approximate message passing, then orthogonal AMP, and then there are this, for example, approaches where you just have iterative algorithm you unfold on deep neural architectures. So if you have 100 iterations, so you have, say 100 layers of a neural network. So what we use is the following. This is just, small illustration of what we are doing. If you have here this constellation map, so in fact you relax the problem to some kind of feasibility problem, and then you construct the algorithm that converges to some set which includes, the point for which the function you are trying to maximize attains its maximum. And I think I want to, here it says illustrated, and maybe I can go through, very fast through this. So in fact, you can see here you have a function, and then you want to optimize this function over the intersection of two sets, and one of the sets is non-convex, so this is a problem. And then you pose a problem in a Hilbert space, you relax, you make this convex, and then you omit the objective function, you look for a point in the intersection, then construct an algorithm that converges to a point in the intersection, and now this is a new component. You perturbate your algorithm to force this, towards the point you are looking for. So you in every step, you try to force your algorithm in the desired direction. And from a mathematical point of view, the challenge was to ensure that the convergence properties of the algorithm are not lost. You still converge to some point in the intersection of these two sets. Good, I mean, here there is a simulation. So in this simulation, the algorithm, APSM algorithm, this is what we propose, is the best one when you compare to OMP and LMMSD, which is bad. But here you can see that for the starting point, you have to choose some parameters. And this is, of course, a little bit a problem, how to choose these parameters to have such a good convergence. And this is, where you can use neural networks. In fact, what you do, you take this algorithm with these parameters, you unfold on a neural network, and train the neural network to find the right parameters. And this is what we did. And here we compared with other algorithms. And here our algorithm is not the best one. The best one is OMP net2. This is this one. And there are two of them, and our algorithm is here. So it's worse. But if you look at the complexity, you can see computation time in microseconds. This is, our algorithm for microseconds, and OMP is quite complex. So you have these gains. So there is some kind of trade-off between complexity and performance. Good, I mean, we also implement this together with NVIDIA. So we use more or less representing kernel Hilbert spaces, so you can choose Gaussian kernels and linear kernels, and then do these projections in parallel. So you have some kind of massive parallelization, and GPUs are good for this because it's like if you are interested in massive parallelization, you can do it very efficiently on GPUs. But it took for us really, I don't know, more than 1 year to achieve latency here in this case of 0.4 millisecond. For the whole operation here, you had 6 users with, and at the base station we had 3 antenna elements, to perform this task in 0.4 millisecond. And I have to say that this was a hard work between, say, NVIDIA engineers and my people, and the essential was this co-design of hardware and software. It's not so easy, to, for example, come up with an algorithm and hope that, if you implement this on some GPUs, you will satisfy this strict latency constraints of 5G. Good. So let me say something about task-oriented communication. First of all, I mentioned this, I think, yesterday. We are talking about AI. Everybody is excited about AI. But there is this paradox. Now I know the name, Moravec's paradox in AI, and which says that painting and writing are less demanding for AI than sensory, motor, and perception skills. So in other words, problems that are simple for AI or for us humans are extremely difficult for AI and vice versa, right? So if you, for example, take, I don't know, there is a Turing test and large language models, I think that they would pass, Turing tests. I mean, Peter told me that even, there are some reports on this, that you cannot, differentiate between ChatGPT or humans and so on. But there is something called a embodied Turing test. This is the extension of the original Turing test and includes some kind of capability of interaction with a physical world. Yeah, for this you need, for example, navigation, some kind of perception skills, and you have to you have to synchronize perception with coordination. This is like catching a ball. For us humans, it's easy, but now build a robot that can catch a ball. So this is just easy for us, but it's extremely difficult for AI. Why is it relevant? Okay, so we had this demo. What you can see here is you can see 3 robots, 4, and two obstacles here. And the goal here is that the robots, they should, that it's about formation control. They should, achieve some kind of form. In this case, it's a star. So it means that, it's not, what is, important is not the absolute position of the robots, but it's just relative to other robots, so that, they can form something, like in this case, a star. So you can see, first of all, I mean, they have to avoid these obstacles, and then they have to form, this star. And why I'm mentioning this? I'm mentioning this because it is fundamentally different from classical communication. Here they collaborate, and then they have to reach consensus. So the objective is to reach consensus. They have to agree on relative positions to each other. And this is a big chance to reduce the amount of data you transmit over the wireless channel. In fact, in this case, you don't need to transmit individual measurements from each robot. You only have to compute some functions of the individual measurements of each robot. And this is task-oriented communication, and we could also say it's a semantic. I don't know, in fact, what is the difference between semantic and task-oriented? People exchange these notions. But the one thing is that, that here there is a huge potential to reduce the amount of data you transmit, for example, in the uplink. The second thing is that here you have to equip the robots with some capabilities. They have to navigate. They have to just, for example, navigate with respect to each other and so on. That's why we need this next generation AI. And this is related to the previous slide I showed. So what we do is the following. First, we use the spiking neural network. So it's called, this task semantic over device edge co-inference. So we have, some kind of sensor. I have also one video spiking neural network that extracts some features, and then the features are sent over the wireless channel, and then there is, another artificial neural network at the edge side to extract the information which is needed to perform the underlying task. So we built this demo. Here, maybe I can start the video so you can see the robot. I mean, there are 2 robots. They are connected via sidelink, and there is homomorphic processing. This case is camera. We are going to replace this by a sensor. And then here the goal is classification, right? So you have to classify the gesture. It's a gesture recognition. So that's why you can significantly reduce the amount of data. You don't need to transmit, you don't need to track the movement of the hand. Yeah? Everything you have to do is to classify. And this is just, semantic communication. And this spiking neural networks are highly energy efficient, so you can just dramatically reduce the energy consumption in such a system. Okay, so now also with Bosch mainly we have a project where we have, these robots here, and then they are equipped with some semantic encoding and transmitters, and then there is, there are digital twins of these robots in a cloud, and then they don't communicate directly, they communicate, the digital twins of the robots communicate in the cloud. So here the problem is, of course, the uplink challenge, but you can use semantic communication because here the task is to synchronize, to update, to keep this information in the digital, in the cloud, to represent, you know, the robot appropriately. So the last, I have only 3 slides, so I think that I will manage this. It's sub-terahertz communication, because also I saw here some interest in sub-terahertz communication. And the first thing, I was once visiting, you know, I think it was Tom Marcetta who said, if you go to sub-terahertz regime, increasing or maximizing spectral efficiency is bullshit, more or less. Why? Because you have a huge bandwidth, right? So you don't need to maximize spectral efficiency. And in fact, many people forget that in information theory, there is inherent trade-off between spectral efficiency and energy efficiency, right? So if you increase the energy, spectral efficiency, you have to decrease the energy efficiency if you operate on the, say, on the optimal boundary. So there is some kind of inherent, which we also, a trade-off which we also observe in practical systems. So here the idea is, okay, so we have sub-terahertz, so we are, say, transmitting at 160 gigahertz, I will show in the next slide. And the target is spectral efficiency. Spectral efficiency is neither needed nor welcome, because, say, we have 30 gigahertz bandwidth. And the target is to have low spectral efficiency, and this is the great opportunity to increase the energy efficiency. So, but for example, for this, what we need is high directivity. So we need, you know, for example, narrow beams, and this is a spatial filter, and then the spatial filter will kill the most multipath components. So in fact, as a result, what will you have is just more or less flat channel. And that's why, you know, if you have a flat channel, you can use single carrier linear MMSC. Even in most cases, you know, no equalization is needed to achieve this low spectral efficiency. And of course, with this, you will decrease the energy consumption significantly. We evaluated simulations. It's based on in collaboration with Roda and Schwarz on measurements. There is also a paper about this. So if you're interested, I will refer you to the paper. So, and now also we demonstrated this at ICC in Rome. We also demonstrated, you know, here transmission over 320 meters between 2 buildings of the Fraunhofer Heinrich Hertz Institute. And here the idea is, Slobodan was talking, everything should be in software. What we say is, maybe we should go back and implement some stuff in analog domain, not even digitize, only analog domain. And then we use these Rothman lenses. They are highly efficient to generate here 8 beams. This is not, you know, simulation. We have these prototypes at 160 gigahertz. And for example, what we presented, that's also reported in this paper, here we have transmission over 9 meters, and then we created the blockage here, and then there is an algorithm, you know, scanning all the beams, and then automatically the transmission changed to reflected path. And then the loss was like about 3 or 4 dB, but still we were able to communicate. So I think that this was the first proof of concept of dynamic beamforming to support blockage mitigation at in the sub-terahertz regime. So now in parallel we developed sub-terahertz sensing. So I think that there is some kind of debate about usefulness of sub-terahertz or using sub-terahertz frequencies for communication. But sub-terahertz, you know, the sub-terahertz frequencies are interesting in the context of sensing. So that's why we developed, you know, the sensing part, and now we are combining these two to have integrated sensing and communication in sub-terahertz regime. This is just, you know, more or less standard setup to generate this Doppler delay maps, and based on this we could do some kind of machine learning. So you can see carrier frequency is 160 gigahertz, bandwidth 4 gigahertz. With this we achieve range resolution on about 3.75 centimeters and speed resolution below 10 millimeter per second. And here there is also a simple demo. You can see here Michael, it's a group leader in my department. So you can see we can do ranging, very precise ranging, and on top of this, even we didn't implement AI, but some kind of finite state machine to do simple classification of, you know, of something, in this case, waving or walking. And yeah, this is a simple example of deep-band sensing, but I mentioned this in the panel discussion that we would like to use this technology, for example, in hospitals to capture vital parameters of patients and things like this. I think that's it. Thank you very much for your attention.
Thank you for the very informative presentation. So we're gonna take questions now. So yeah, okay, you keep that.
Thank you, Doctor, first of all, for your nice presentation. I wanted to ask you a question about the energy efficiency that you mentioned, because yesterday you mentioned that it was unrealistic promises that the communication group did for 5G. So how can we guarantee that the things of energy efficiency that we're promising towards 6G is realistic or not? Thank you.
I don't promise anything. I said, if you want to have a hope to reduce the energy efficiency, you have to change scaling laws in your system. And then I can prove mathematically, theory is, I have to say theory is relevant if it's negative. So if something doesn't work in theory, it won't work in practice. Do we agree on this?
Yes.
Okay. So you can prove in theory that in fact, if you want to change, I mean, there is a famous paper of Gupta Kumar, 2000, capacity of wireless networks. He doesn't prove, you know, the capacity, he deals with scaling laws. And this is a fundamental paper. And then there were some extensions, you know, for example, because he considered ad hoc network without infrastructure, and he showed that if you treat interference as noise, then on average, the throughput per user scales like 1 over square root of n, and n is the number of users, so it goes to 0. So this is a bad scaling. You have to do something, and there are two ideas. Either, you know, you let all the nodes to cooperate, extremely challenging in practice, or you add infrastructure. But in theory, we can show that the number of base stations must grow sufficiently fast. So, I mean, Slavomir said that more or less, I mean, in his scenario, even you had something like personal base station, 1 base station per user, right? So you, of course, I mean, this is something you would get wonderful scaling laws in system, but capex is not so good, right? I don't know. If I go to network operators, they are not happy about this idea, right? So the idea is to have densification sufficiently large, and on top of this, of some collaboration. So it's a combination of these two. And this is for me self-remissive MIME. But I am not saying that you, in the end, if we implement this in practice, but I have to say that all the network vendors, they work on this, right? It's not only us. This is not our idea. And then if you implement this in practice, it might, you know, the result might be that in the end, you know, the energy consumption, you know, will be the same or even worse. I don't know. It's also implementation issue. For example, I mentioned that we are now working on the demo, and our main challenge is synchronization of these access points. Yeah. So it's not clear how to cope with the lack of perfect synchronization, and to get the perfect synchronization in such systems, it's a big challenge. Yeah.
Okay, thank you.
Okay, well, with that, we come to the end of the session. Please join me in thanking Professor Stanza for the talk. Next, I will ask both Professor Alim Gebel and Professor Daniel to come to the stage and take it from here. Thanks.
Thank you so much. Let's kick off the closing of Next G Summit and by thanking our esteemed speakers. And for that, I would like to invite, first of all, our VPRI, Professor Ali Sheikhi and Professor Danielle on stage to thank our esteemed speaker one by one. So we'll try to wrap it up as soon as possible, inshallah. Okay, so first of all, we would like to call and thank Dr. Michael. Please join us on stage so that, yeah, please thank Dr. Michael. Thank you. Dr. Michael, thank you so much. Okay, next up we have, thank you so much, Professor Muhammad Salim. Thank you so much for an interesting presentation and joining us here in Next G. Please join us. Thank you so much. Thank you so much, Professor. Next up, we have Engineer Amun Dalal. He's around. Okay. We'll ask for a spectrum from him later on. Then we have, thank you so much, Dr. Slaumir Petre. Thank you. If you can join us on the stage. Thank you, sir. Thank you so much. Thank you so much, sir. Thank you so much. Next up, we have Professor Peter. If please, thank you so much. Please join me for thanking Professor Peter. Thank you. Thank you. Thank you so much, sir. Thank you so much, Professor. Thank you so much. Please join me to thank Professor Slaumir Stanzia. Sir, please join us on the stage. Thank you so much. Thank you so much, sir. Thank you. Next up, we have our own Dr. Ali Hussain Mukabil for his keynote speech. Thank you so much, sir. Thank you, sir. It was all for the speakers. Thank you so much, sir, for joining us at this stage. Thank you. All right, so during the breaks, you must have seen the interesting posters outside, and there was a competition going on, if some of you know about that. And for that, I would like to invite Professor Azzuddin on stage. Sir, please join us. We are, waiting for the winners to know who is going to win the prize. There is a cash prize also, and so everybody's awake now, right? Yes. We had a committee of 3 judges. There were grades, and we took the average. And Professor Azzuddin will announce the winners. We'll start from the 3rd winner of the poster competition for Next G Summit at KFUPM. It is?
The 3rd one is Mahmoud Salim.
Mahmoud Salim. Dr. Mahmoud is the postdoc at IRC CSS. Congratulations, Professor Mahmoud, Dr. Mahmoud. Okay, next up we have the 2nd winner of the poster competition.
The next one is Farouk Kumba.
Okay, that's going to be me. That is contradictory, so I'm so sorry about that. I did not know about that. I did not know about that.
Yeah.
Definitely.
He doesn't know
Okay.
about it.
Yes,
for
yes.
sure.
Okay,
Nobody
so
knows.
next up we have the 1st winner of the poster competition
The
at
first-
Next G Summit.
The
is
first, who do you think will be the first one? The first one is Kabiru Aliyu.
Kabira.
He's not here.
On behalf of Kabira, we can call.
Kabiru is here.
MashaAllah. The first winner of the poster competition is at Next G Summit KFUPM. Congratulations. Thank you. Thank you.
Okay, thank you very much. Now we are coming to the end of the Next G Summit. It was a really nice experience to have part of this organization. We get an excellent feedback for all attendees, participants. I would like to thank all for making this event a big success. And I would like to announce we organized the 2nd edition, so be tuned on. I got approval by the Vice President, and we'll work to make the 2nd edition much better than this one. I think we are now in a current situation, scenario in which Next G, it's part of our daily life. And the Kingdom has some priorities in our projects, our students, postdocs, faculties, all will be engaged on that. And we need to work together. Research, we do not we doesn't do alone. We need collaborations, partnerships, and we have a strategic vision. And I'm confident the second edition will be much better. I know this was already the first one, but we have room for improvement, but we get an excellent feedback as well. So I'd like to thank KFUPM, special the president, the VP for Research Innovation. Thank you very much for the support. The Center on Communication System Sensing, the Professor Ali Mukable. I would like to thank the Electrical Engineering Department, all the speakers, attendees. Hopefully you have had 2 days of, nice experience. We have learned the discussions. This is the main goal when you organize such events. We have interactions which will contribute somehow to our formation, to our career, creating new networking. So thank you very much on behalf of the organized committee. I really happy to conclude the ceremony and see that we met the expectation, but of course we have room for improvement. And for the second edition, I'm confident we'll be organizing an event with attracting more international speakers. We have more sections. We are covering other topics, make it more diversified, the program. So thank you very much, and hope to see you next year at KFUPM.
Thank you, Professor Daniel, for this excellent summit. You made it sound like it was not good. I think it was excellent summit. It achieves its objectives. And as you mentioned that we will try to do it next time, maybe a year from now. And I hope we'll make it even now bigger, maybe a conference, a big conference related to communication on next G or 6G. I reiterate what Professor Daniel mentioned about thanking all of those who participated in making this event a success. Professor Daniel himself, he put really a lot of effort. Dr. Ali Mugable and the Center of Communication System and Sensing and all of the people working there. Dr. Fahad and the KFUPM Institute for Knowledge Exchange, KICS, they really also put great effort. And I have to really thank them a lot for all what they did, especially really the girls there, they did a wonderful job. We were a bit fighting in the last minute about the organization, but all for the benefit of the conference. So big thank for the organization. Definitely big thank you and appreciation for the speaker. They came from across the world to come here at KFUPM. I'd like really to thank them, and I hope a safe return flight to them, and we hope also to see them in our next conferences or summit or events. I'd like to mention that next time we will double the prices and we will double the number of awards. So it will not be 3, it will be even more. So that's one thing, and as I mentioned that we want this one to be an actual conference in the future. Again, I will say that this summit fulfills the requirement of it. The idea was really to interact together. We know what is the future of communication, and the important thing is, as I mentioned, is really, as Professor Daniel mentioned, is to work together, forge these relations together. And we are in a small world that we really need to act and participate and utilize all our resources together to achieve the impact that we want on our community and humanity even in general. Communication has, I think, a great future, whether in all the technologies that we mentioned, connecting the unconnected, AI, virtual reality, augmented reality, services, the availability, security, everything, privacy, all of that. So lots of things we can do. And if it is only of the relation that we establish from this summit, that will be by itself a big achievement. So thank you. I hope to see you, inshallah, next time.